All right, I think the stream is live. Let me check, because I never know for sure. Yeah, there it is. Let's make sure the chat works. The chat does not work, interesting. There we go. And I need to update this as well. Should have done this before I started. Hey, how's it going? That was fast. I just turned the stream on. I'm still getting things ready here. Where is it? I need to update the title. All right, there we go. Now I can get started. I have a lot to do today, actually. So I need to focus. I'm working on this water simulation, or fluid simulation still. And there's a lot I need to do for this today. Why is the water so slow? So satisfying playing with the different liquids. Hey, how's it going? I've got a lot of work to do today. So I'm getting the stream up so I can focus. Because I can't goof off when the live stream's up. I have this this fluid simulation here, but this is in like a little test bed project. So like, cause I was just really focused on getting the simulation to work. But there's a lot of stuff I need to do to actually get it like ready for the game. So I'm gonna work on that today, ideally. I don't think I'm gonna get it in the game yet today though. But eventually, the end goal is I'll have this working in this project here. If it will compile, I don't know. Just didn't want to go for some reason. Yeah, eventually I get the fluid working in this. But I kind of just have a lot of like debug temporary code in the simulation right now because I was just like working on getting it just implemented. So I'm gonna work through getting that done today. And the first thing I have to do is get a scheduler implemented so I can handle these fluid updates in a more, I guess, robust way. Yeah, I'm just kind of talking nonsense right now. It's fun when I start these streams with zero context. But basically, the first thing I'm going to work on is a scheduler. Because, so you can see my frame rate up here on the top left. It's like 6,000 because I just have it uncapped right now. But the fluid actually simulates at a fixed frequency of, right now I have it at 100, I guess, updates per second. And I can control that here. This is like my little temporary fixed time step thing I'm doing. So like I can put this to like 30 and the fluid will run about a third as fast. So like now it's just really laggy looking. And if I put it like 1,000, then it just goes really fast. The music's really loud. But I need this to actually be a bit more smart than just having this time step thing here. So I started writing a scheduler to kind of divvy up work for the graphics card, because I'm going to have a lot of these sort of operations happening at certain time steps. And if you're not careful, you can have like unbalanced frames in terms of how much like work you're sending to the graphics card. It's actually kind of hard to demonstrate that on this computer because I have a pretty decent graphics card, so like it's hard to see. But like at the bottom left here, I have a little profiler graph, which is basically just like spitting out the frame times as the frames happen. So maybe if I unlock or lock the frame rate really quick. Let's make this like 60. Still hard to see. But at like 60 frames here, in the time step at, let me go back. Yeah, so 60 frames with a time step of 100 updates per second. You'll get some frames that have like one update in the frame and another frame that has like 2 updates. Because like in order to fit 100 into 60, you'll have, you know, about every other frame, you'll have twice the amount of updates happening just to like reach that count. So in this frame graph, you can kind of see like, I don't know if it shows up on the stream because of the compression, but there are little spikes every other frame. And sometimes it's higher than others. I'm actually not entirely sure why that is. So I'm gonna have to figure that one out too. But that's because I'm just sort of like naively scheduling work just on every like other frame. But a scheduler can be a little more intelligent than that and trying to like, and instead of just doing it every other frame, it can try and balance it out such that like all the work heading to the graphics card per frame is sort of like a constant cost, or like I guess as close to a constant cost as possible. So I have this. Let me go to the project. So this is like a better visualization of what the scheduler is going to do. So I guess this just looks like a bunch of noise, but each of these like colored bars is like a set of work, or like a job. And then the height of each bar is like how much time it takes in milliseconds. And these are just like debug. I'm just making just random work to demonstrate the scheduler. But if I go into this project, I'm in it already. And I changed like the amount of work being done. So let's put this to like 100. I'm not sure. Yeah. So you can kind of like see like when I start the thing, it's like kind of chaotic. You know, you get these like crazy spikes. But then as the program runs, it's actually like learning, or it's sort of optimizing the scheduling of the work to reduce the spikes, while still reaching the frequencies that I've defined over here on the right. Yeah, so it's just sort of like trying to keep the amount of work constant, or like as close to this sort of average line as possible. So I need to get this working in the water simulation, because I just made another testbed project for the scheduler. So I'm going to do that now. So I'm actually going to make an engine module for this because I might reuse this for other stuff too. So I'm going to make one called like scheduler. Because it's sort of a useful thing to have. If you have updates that need to happen at sort of like a frame rate independent fixed frequency, but you don't want to have like frames that sort of, I don't know, spike up higher than your frame budget. So let's see, what do I actually need here? Let's see. So I'm just going to copy this code into the project. And then, let's see. So these need to go in the header source file. The job is actually going to be a subclass of scheduler, so I'm going to just put this in here somewhere. I need this too. these doubles or yeah, floats. All right, I think that should just work actually. And then I just need to draw a draw function. So I need this. I'm not sure where to draw this. Let's see. think that is everything I need for that. So let's see. So actually, if we go to the fluid project, what's happening? Undefined symbol. Interesting. Oh, why is it static? All right, there we go. Now I should give like jobs a name or something. Because otherwise this debug stuff is hard to write. So let's do that. And that should give them a color too. What is that called? Frame. Yeah, so I can get rid of all this debug stuff too. Color. I think the budget line is wrong though. Let's see what's going on here. Should be white. I'm gonna make this return a reference as well. Interesting. Am I like seg faulting or something? Interesting. Oh, I'm not returning this. Okay, now I can just use the scheduler for the simulation. Let's see. So this needs a scheduler. Hey, how's it going? These need to be at the top of the function. Oh yeah, this needs to go in there too. Should refactor this at some point. All right, sweet. That was pretty painless. I feel like I should be getting more than 10,000 frames or 1,000 frames though. Oh, so I'm in OpenGL, that's why. Now, if I uncap or I cap the frame rate at like 30, yeah. Interesting. So what's kind of funny about this is that these green lines, these are the CPU readback for like the simulation data. So I'm getting it back from the GPU because you need it for like gameplay reasons. And that's a really slow operation. I have to figure out why though, because I can't, like some of these take 9 milliseconds to do it, and that's not acceptable. Like I can't spend 9 milliseconds of a frame just reading back from the GPU. So I think there's ways you can do it like asynchronously, but clearly that's not working here. Like the actual simulation itself, you can't even see the bars because it's like really cheap. So if I like turn these, let me see. Like if I just remove the readback job. Where was that? Yeah, apparently the simulation takes only like 0.01. That doesn't even seem right. That seems really fast. Let me render dock that. Let's see. I think my timings might be a little off here. Yeah, because this pass alone, this one takes, well, let me just do this a couple times. I don't know how reliable these render dock profiles are. It's like 100 microseconds per frame. And what, there's 1,000 microseconds in a millisecond, I think. So I should be seeing like 0.1 instead of 0.01 for the time. I'm gonna see if flip-flopping, where is it? I'm gonna see if flip-flopping these actually increases the frame rate. Because the slowest thing about this is doing the read back to the CPU. Let me just turn it back on. Yeah, because these green bars are the read back, and it increasingly gets more expensive for some reason. So it could be that the it's just bad synchronization. Yeah, because I'm doing this like fully on the GPU. But yeah, you need the water data on the CPU obviously because it's a game. Like you need to interact with it and get values from it. And that's like the big downside of doing GPU stuff is you need to get the data back. And it's like really expensive to do that because it forces like it forces a synchronization point between the CPU and GPU. Because normally the GPU kind of like works ahead asynchronously, and then you have like double or triple buffering for your actual frame buffer. So like your CPU and your GPU aren't always like in sync. Most of the time they're not in sync. But when you read back to the GPU, not only are you paying like the bandwidth cost of like sending those back over, the data back over, but then you're also like forcing the GPU to kind of like finish its work and then stall it, send the data back and then resume. And that's bad. But there are ways to do it like if you don't need the information immediately, there are ways to do it asynchronously, I think. Or like the GPU kind of writes to a buffer whenever it's yeah, that's an idea too. Yeah, I'm just not sure how that would work for like physics stuff. Because like what I really care about is getting like the water volume at a given position and like the velocity of the water. But I also need it for like when I unload a chunk and I have to save it to a file. I need to like know how much water was in a given spot. But yeah, it's a tough problem. I mean, the performance isn't like killer. Like I'm not like, this isn't a game ender, and I'm only doing this for the water simulation. So this is like the only thing in this game that will ever have to talk from the GPU back to the CPU. So like maybe the cost here is fine. It just seems really high. Like the simulation costs basically nothing. Like you can't even see the simulation bars here. But the readback is super expensive. What's it look like in OpenGL? I wonder if there's like a driver thing too. Like, okay, interestingly, OpenGL, well, I don't know. OpenGL is about the same. It seems more stable though, which is odd. I could have very well just messed up my code for this as well too. Like the DirectX code might just be incorrect. Now I could just request this at like a lower frequency too. Like, do I really need to get the updated data 30 times a second? Probably not. Like you probably get away with like 10 times a second or something. So like, let me do just like a really low number. Like let's do 10. Let's put the frame rate back to 60. Yeah, because if you do it 10 times a second, it's kind of hard to tell actually, but I think this is more, the green bars are smaller here because the GPU knows that it can do more work ahead of time. Right, it's not like flushing the pipeline because like the last frame that needed that to happen was like 5 frames ago in this case, or 6 frames ago, I guess. So that's interesting. So like if it needs it every frame, then you're kind of just screwed. Is that the same in DirectX? Yeah. So like maybe, yeah, you just settle for doing it less frequently. But let me try alternating the frames. Because the way I'm doing this right now is I have like the simulation. It happens in 2 render passes. So like there's one part of the simulation simulates the water as particles essentially. So like this is what this render pass is. And it like basically distributes the mass and the velocity like through a grid. And then there's a second pass which kind of it simulates, or it basically takes the particles and then puts them back onto a grid. And then this is where the viscosity is also calculated. So like attractive forces happen here, like this line. So this is like the actual simulation. Now, what I care about reading back to the CPU isn't, the full simulation, because I don't need all of the intermediate values. Like what I actually only need is what I output in this shader to like a temporary buffer. And I'm packing the mass. So there's gonna be 4 fluid types actually here. So like I have 2 of them being packed into 2 integers. And then I have some unused stuff I'm gonna use for other stuff later when I get to it. But I have a few other simulations too, I think, happening. But it's this buffer that's actually being read back. And currently in the code, let's see. Let's see, where is it? I'm like generating this readback buffer, filling it with data, and then I'm immediately trying to read it back. So if I just try flipping these, like flip equals false or true, I guess. So if flip, we'll do this. So like 1 update tick will just write the buffer, and then some time will pass, and then the next tick will read it back. And this might actually mitigate some of our problems, but I don't know. I'm just spitballing here. So here, let's do this. Flip equals not flip. So then every time this function runs, it'll just flip-flop between what it's doing. I'm just gonna see if this is any better. So let's put this back to like 30. Yeah, I don't know. Does that look better? It's hard to tell. Let's put well, I guess technically this should be 60, but let me see. So if I put the frame rate back to 30, so this always happens one frame. Yeah, you can see the expensive frame is the one that's doing the readback. Okay, so that really didn't do anything, I don't think. Because if I just get rid of that, let's see. I just keep getting lost in my function. So if I just get rid of this and set this from, rather than 30, put it to 15, should be the exact same thing. Okay, interestingly, it's actually cheaper doing this. That's so odd. I wonder why that is. So if my frame rate is 60 and I put this to 30, how expensive is that? So I guess moral of the story is just alternate your readbacks between frames, because I guess that allows the GPU to like not force a flush probably, because it can work ahead of frame. If I had to guess, that's what's happening. Let's put it like 20. Maybe this is even faster, because sometimes they're triple buffered. It's hard to tell if that's faster. And I mean, just looking at my mouse, like I have the water volumes being rendered. I don't know why I have Fs on some of those. They're being rendered at my mouse position, so you can like see the values changing pretty fast. And this is only updating 20 times a second, so like that's probably fine for gameplay reasons or gameplay uses. So I guess I'll just keep it at that. I don't know. It's one of those things you can kind of fine tune later if you need to. So the scheduler was kind of the easy part of this. The hard part is I need to break this simulation up into chunks today. Because currently, if I zoom out, so this kind of like blue area, this is like the simulation volume, I call it. I don't know. Oh wow, it got really expensive when I zoomed out too. This is the simulation volume. So this is, I think, 8 by 8 chunks worth of liquid being simulated. And this is what I need for the game. This is kind of like my target here, is having about at least this much being simulated at one time. And how I was originally thinking it was going to work was that basically the view, your view would be centered in the middle of this volume. And there'd be like a boundary around your view that you can't see, but like water is still simulating there. Because it'd be kind of odd if you had like a giant wave that like went off screen and it just like froze. So there's a little buffer region where it's gonna like keep simulating. But then I realized this is actually kind of wasteful, because the chunks that I have loaded in the game aren't always gonna be guaranteed like to be a rectangle or a square around the view. Because like I'm not gonna load in sky chunks if they're not like, if they don't contain anything. It's kind of stupid to waste RAM like loading in a sky chunk. Yeah. So yeah, but yeah, right now this simulation works just assuming it's a giant square. But I want to break it down so that it simulates like chunk wise. But it will still be a giant square. But I want to be able to like assign one of these little like chunks will represent a world chunk, and the chunks might not actually be like next to each other within the simulation. But the water should still like, I don't know, it's hard to describe. I'll just like have to start doing it, and then maybe it's more obvious what I'm doing. But basically I want this simulation volume to kind of act like a pool of like a chunk pool of potentially simulated chunks, and I can assign one of these like simulation chunks to an in-world chunk, and it'll just like have to figure out what chunks are surrounding it. I don't know. I'm doing a terrible job explaining this, but it's going to be kind of tricky, I think, getting this to work. And I'm actually not sure if it's worthwhile. So yeah, we're just gonna try that. So I need to change a lot of stuff for that, but let me first save this work because I might want to undo it. So scheduler and yeah, this is actually gonna be a pain. All right, let's just do it. So the first thing I need to do is actually add a concept of chunks into this simulation project. Yeah, it's gonna be kind of annoying too because I have like this little project, and eventually I'll need to get this into the game itself. But I need to like make a mock version of the game in this, so I can actually like sort of develop this. So let's just do something. Maybe I'll make a new file, chunks. This is gonna be like as basic as it gets though. So let's speed run a chunk implementation. So what is a chunk? A chunk has, I guess, an ID. It will have a flag. It'll also have maybe a simulation ID. And I'll just make these negative for now because that will denote an invalid ID. And then I think that's fine actually. Maybe I give this some data as well. So let's see. Fluid data. Fluid. Let's just call it fluid. So this is where I'll read the fluid data back into on those like read back ticks. So each chunk kind of has its own buffer of fluid data, but I'll do this later. Let's first just get the chunks working. And then we need like a thing that just handles chunks. So void init. Yeah, one of the other big problems I'm gonna have to actually solve here too is that the simulation will have to be synced across multiplayer eventually, which is a really tough problem because multiplayer in general is just a pain in the ass. But it's a problem because the simulation, when it happens on the GPU, you're not like actually guaranteed to have deterministic floating point math by default, like on a GPU, unless you're like in a compute shader and you explicitly turn it on, which I am not. I'm actually doing this in a fragment shader. So you have one source of error being that you just don't even have deterministic floating point math, and that sort of butterflies out into like chaos. The second issue is like if you have multiple clients connected to a server and they're all simulating like the same region of water, you just have latency within the updates. Like if I place a block, like that block will appear immediately on my screen, but it might take like 100 or 200 milliseconds to appear on the other player. And in that time, you have 200 milliseconds of water simulating like through the block. So there's just like all these modes where you can accumulate error in like your simulations between clients. But ideally, everyone sees the same water. So you like need a mechanism to sync those. Which means the server will have to simulate the water as well. And I think the easiest way is to just have the server sync, like send forced like sync updates to all the clients. That will basically like force the clients to have a correct version of the water. And I'm not actually sure what that system will look like yet, because I don't know. I just don't know how big of a problem it will be. But anyway, let's write this. This needs to be here. How much fluid data does a chunk have? It's like 64. Let's get some of our helpers in here. But yeah, so you have the multiplayer problem, and then add the complexity that you're like simulating this on the graphics card. So you have like, you're not only talking to like a server, you're also talking to the graphics card from like the CPU's point of view. So it's like, in a lot of ways, you can kind of think of the GPU as like a separate instance of something running that you just kind of like send work to. So you're gonna have to like figure. Oh wait, I'm not doing this right spot. The chunk needs an init function too. And I'll give this an ID. I actually don't care about freeing right now, but I'll just add the functions out of good habit. Alright, so I guess, let's see, how many chunks do we actually have? So this thing needs an array of chunks as well. So just make everything public. And so count equals, so the number of simulated simulated chunks is that so let me think. 512 divided by 64 is 8. So I think that should get us the amount of chunks. 512 times 512 divided by 64 divided by 64. Yeah, okay, that makes sense. Let's make this an int. I always forget what the formula is to get the one-dimensional index from the an XY. Hey, how's it going? So I think it's what? It's like y times width plus x, I believe, gets you the index. So we'll return that. And we need like a simple draw function or something. So like, so that way we can just draw the chunks really quickly. So let's see, let's copy this. I'm not currently. I'm just kind of like making it for fun. I do want to sell like games that I make in the engine, but I don't really have any plans for the engine itself. At least like commercially. Like I do have the source up on the GitHub in the description, or like I think it's kind of outdated now by a few weeks, but it's out there if people want to use it. But I think it's like, I don't know. I don't know if I'd recommend people use the engine, because it's like, I'm just really writing it for what I'm doing. Not like general purpose, just commercial reasons. Okay, so let me get back here. Yeah, I just don't have enough. I think it'd be fun to make a commercial game engine, but there are like so many out there that one, it's just hard to compete with that. Like what do I offer that other engines don't have? Like maybe compile times, because my engine compiles really fast, because I've kept the code very concise. So like maybe I have that one aspect going for me, but when it comes to everything else, it's like I don't really have anything new to bring. I'm just mainly doing it because I just enjoy doing it. It's just fun writing kind of low-level code. All right, let's see. What am I doing? So. Give these things like an outline. Just want to make sure that these actually render, that any of this code actually works. Let's see. I guess this should be times chunk size. And what did I forget again this time? Forgot to put a semicolon. All right. And then let's just add this in here for now. So let's Okay, we have chunks, which is a good sign. And let's see, what else should I do? All right, so let's get that actually in the other project, the other source file. Let's see. I'm not sure where I want to put this stuff. Just put it like here, I guess. No, I'm not. I don't need to because it's not actually, there's no real particles here. So there's no need to partition neighbors because I guess technically it's partitioned by the nature of it being a simulation on a grid. Yeah, thanks. I'm really I'm really happy with how it turned out because I went into this kind of blind. I've never written a fluid simulation before. So it was really a grind actually. I just showed off like the working final product, but there was there was like a painful couple weeks of just it wasn't working at all. Yeah. In theory, the one I have here, you could do this in Game Maker. It's actually not that complicated. Well, it's kind of complicated. I would be lying if I said it's not complicated. But you could definitely do this in Game Maker. It's kind of similar to the simulation we used to have in the old version of Vitality, except the old one, it didn't really handle like velocity correctly. So the fluid in that game could only flow down and to the side. Whereas this simulation is actually a more, I guess I can't say physically accurate because it's not physically accurate, but it's closer to looking that way, I guess. Let's put that there, and init function. Let's just put this way up here. And let's draw this as well. Let's draw this where we're currently drawing the chunk outlines. So I'm not sure what the scaling has to look like here. Let's just try these values for now. And error, of course. Okay, the scale is just wrong. It's like off by a factor of like 4, it looks like. So let's just multiply by 4. Yeah, there we go. Now we can make the chunk lines less intense. And we can get rid of the old code, which we did already, so delete those. And I'm gonna uncap the frame rate again, or make it like 1,000 or something. Yeah, there is one downside with this simulation. So I have multiple fluid types in here. So like here's like the lava and the water and the oil as well. And they do interact with each other. Like you can put water in oil, or I guess water in lava. And in the game, they'll like occasionally place blocks between them, you know, like Minecraft when you combine water and lava, creates like obsidian. So the game will do something like that too. Right now in this engine, or in this little project, I don't have obviously the actual game stuff, so I can't put blocks. But yeah, so they interact. So like if I put the oil on top of the water, you can see like there is a separation between the two. And the water has like a different viscosity than the oil, which is kind of cool. So like, I don't know, it kind of flows into it. The downside though is because I'm not actually simulating particles here. I'm simulating a grid that behaves like a particle. I don't actually have the ability to like separate the oil from the water now. So they've kind of combined their masses, I guess. So like the oil will just sort of always be in the water now. Like the oil, ideally the oil would float to the top, right? Because that's like what oil does in real life. But I just can't do that easily with the way I'm doing the simulation. The blocks are actually 16 by 16. They're like, well, they're 16 by 16, but I have an 8 pixel buffer around like the edges where I can add like extra, I don't know, detail. Oh, in chunks, yeah. It's 32 by 32. And I'm simulating the water 128 by 128 per chunk. I guess maybe the chunk is kind of confusing because I have, so I support like slabs and stairs and stuff. So like I call those micro blocks, which is like, okay, if this block is a stair, right, then it's actually like, you know, 3 little blocks instead of 1 big one. So it's like from the simulations perspective, the chunk is 64 by 64 because you have like half resolution on the blocks because of the micro blocks. So I guess you could technically say that it's like 64 by 64. And then for the fluid to look good, I simulate at double that resolution. So like each little micro block can have additional fluid particles like within it. Because otherwise, if I had like a really thin gap like this, the water wouldn't be able to squeeze through it. So I kind of had to like update, like bump the resolution so I could simulate this sort of stuff. Yeah. Yeah, like the one big downside with GameMaker is they don't make like packing variables very easy. Like in this engine, like with C++, I can just like pack stuff however I want. So like each block, if I just go to the data really quick. Let's see. It's like in here somewhere, block data. Here it is. Yeah, so like this structure here is the amount of data I store per block, like in the grid. And I'm like, so each of these is actually only, I guess 8 bytes large, but I store a lot of stuff in here. Like I store like the ID, the microblock, there's like some state related stuff. And I can store all of that in 8 bytes because you can like just pack stuff really efficiently. It's like I like allocate 12 bits of that goes to the block ID and stuff. And you can do that in GameMaker. Like we did that in the GameMaker version of Vitality. But you have to like do it. It's just annoying to do that. Cuz you have to like create a buffer and then like index the buffer. And then like do, you know, bit manipulation just explicitly. All right, so let's go back to the fluid. Maybe I'm mistaken on this, but I remember structs being like insane in GameMaker. I kind of stopped using GameMaker around the time GameMaker 2 came out. Or that's not true. I was using GameMaker 1.4 for like a long time because we were working on Vitality even after 2 came out. So like I didn't really use GameMaker with structs, but I remember they were like crazy. It was like every time you create a struct, it was like basically I wouldn't say it's an object, but like in C, and C, a struct is literally just like, it's like an alias for just a group of bytes. Like a struct isn't actually a thing. It's just like a syntax thing. So you can, work with variable names on bytes rather than just like doing byte stuff directly. But in GameMaker, it was like actually like allocating memory sort of dynamically for structs. And I think I remember looking it up. It was like doing like hash map lookups when you like try to access a struct. And they were like garbage collecting the structs on you. So it was like actually using structs are really bad if you're trying to use them for big stuff, because you're like incurring all this extra cost from the garbage collector. They might have fixed that. Yeah. I don't know how else to describe it other than like an object. But I think the reason it's like that is because like you can, I don't know how to describe it. I don't want to like speak about GameMaker on stuff I half know about, but I just remember wanting to use them because I did do some stuff in GameMaker too. Like I wanted to use them, and then I realized they were like actually a bottleneck for what I was doing. I was like, well, I might as well just do the old way. Yeah, that's like exactly what I tried to do. I was like, wow, I can use structs now. I can make my block data a struct. And then like my FPS was terrible. And I think this is during the time before they fixed the garbage collector. I think there was an issue with the garbage collector for a little while where it was like causing let's make sure my microphone's not clipping. Where it was like causing like garbage collection spikes to happen. So like I was getting these crazy spikes and I couldn't figure out what was happening. I don't know. I think they fixed that though. I mean, I hope they would. Because GameMaker Studio 1.4 didn't have the garbage collector, I don't think. At least I don't remember it. Yeah. I will say I do miss GameMaker because it was like really fun doing complicated stuff in GameMaker. Because like the engine doesn't give you a lot of like both the engine and the language don't give you a lot of tools to actually do that stuff. Yeah. All right, so let's get back to this chunking stuff. Yeah, like the main reason GameMaker is slow is because of all the memory stuff it does. Like, at least like the deeper I've gotten into just programming stuff, it's like the more you realize that basically the bottleneck with everything is just memory. It's like usually the computation isn't actually slow. It's just like accessing memory for the computation. And like once I realized that, it's like, well, I don't know, if GameMaker's wasting like 115 bytes per struct, that's insane. Because like the L1 cache in a CPU, which is like the fastest cache on a CPU other than like what's in your registers, is typically 64 bytes. So like you can't even have one whole struct in a cache line. So like every time you iterate over structs in GameMaker, I guess you're just like, I don't know, incurring a cache miss. So like it can only be as fast as the memory bandwidth of that cache miss. And like to me, it just seems like such low-hanging fruit for Yo-Yo Games to like optimize that, because it's not like the language itself is bad. It's just like they're not being very efficient with memory, I guess. Easy for me to say though. Obviously, there's a lot that goes into that, but yeah. But I'm just kind of rambling. So back to the chunks. I'm not even sure how I want to do this. I think the first thing is I need to update these shaders to use these texture load functions, because I think these are broken right now. Let me just try them. Here's another thing I was experimenting with. So you can either sample a texture or you can like load from a texture. So like in OpenGL, this is called texel fetch, I think is the function. In DirectX, it's like .load. And that basically acts like an array, like index into the texture data. And that's not, I don't think that's actually faster if you're not using bitmapping compared to sampling. But I realized that if you have a non-floating point format texture in DirectX, you can't actually sample it. You're like forced to use the load equivalent function. So I like started to implement this, but I'm gonna need this for what I'm doing today. So let me just make sure this works. Let's see. This probably just failed catastrophically. Or not. Did that really just work first try? Okay, I guess I did have that working. Wow, I'm surprised. Make sure OpenGL is also working. Yeah, OpenGL is broken. What is happening? All right, so it's not fully working. Interesting. I wonder what part is going wrong. It's kind of fun though. It's like crazy. It's like worms. I wonder why OpenGL is broken, but DirectX is fine. Okay, the question is which render pass is breaking for that. Let's see. Index. I guess the question is what is OpenGL doing that is opposite? I mean, I haven't actually tried with 1,000 elements. So it's very possible that mine has the same problem as you. But I think, I don't know, let me see. I don't know if this still compiles. Yeah, like I have the scroll bar, but I'm doing it the same way you just described, where I just use like a scissor before I draw. So it's just like, I draw the stuff at like the offset from the scroll bar. But then I set the scissor first, so like the contents outside of the window don't actually like draw. And that's all I'm doing. And like some smoothing stuff, just to make it look smooth, but it's been a while since I actually played with my little text editor. Can't believe I wrote a text editor. I guess it depends. Like, are you able to render dock it? Because you might be able to render dock and see what the bottleneck is. Like if I launch this with render dock and just, I don't know, capture this. And then you can use the little profile, little clock icon up here. And then it'll give you times on the side here of this little, like in the duration section here. So this will at least tell you like what draw call is like causing the problem. So like my most expensive one on here is actually this one probably, which makes sense because I'm just rendering a bunch of text in this one, I think. It doesn't give you, sadly, it doesn't give you like a more detailed breakdown than that. But that could at least like tell you which part of it is slow, if it's like a GPU problem. All right, so let's see. Let's figure out why this is broken in OpenGL. It like almost wants to work. It's like sampling the textures incorrect, like the collisions incorrectly or something. Because the actual physics seems fine. Let me just see if I'm missing a load somewhere. I don't know if this is right. So if I just like turn these off, is it the collisions? Let's see. And this one, I need to do that too. Okay, so it's not the collisions. Is it this? I'll just turn these off until it works. Is it this? Okay, yeah, it is this file. I don't know what's happening. Is it really that? I hate when there's an issue that just affects one of the graphics backends but not the other. Because then you're like just going line by line trying to figure out why. X, Y, that makes sense. Is this supposed to be... I guess this is supposed to be half the resolution. Right? Yeah, you might just yeah, I don't implement that at all in mine. I just loop through everything. I'm trying to think of how you could do that though. Like the only thing that really comes to mind is you might have to like partition it or something. Where like rather than just having yeah, I'm actually not sure. You probably have to partition it though somehow. It kind of like reminds me of like when you do like collision detection, and you have to like partition the world. Otherwise, you're like checking collisions against everything. It's kind of like it's like the same sort of problem here, except yours is just like elements within the scroll region. I'm kind of surprised that 1,000 though would actually cause a problem. That's like not a huge amount of things. Geez, why is this broken? This is really annoying. Let's go back to DirectX. So DirectX is fine, interestingly. Let me just verify that this is actually doing stuff though. Let's see. I bet it's because these are flipped upside down. If I had to guess. Just make sure I didn't leave one of these uncommented on accident. So I have this annoying problem where, well, it's not my problem, it's just a problem. It's an annoying problem where DirectX and OpenGL, they store their texture data like flipped opposite from each other. But when you use these texture load functions, it doesn't correct for that. So like I have to manually correct for that. So like on OpenGL, I need to like 1 minus the index, like the position, like the Y value, so you get the right one. And I bet that's the issue here. Let me just verify though. So like I think OpenGL, I flip this in here somewhere. Yeah, like I'm flipping it here. So let me see what the output code looked like for that. Wait, why is this using... Oh, I need to recompile. Yeah, so... Output, generated, shaders. It's this one. Yeah, so like here I'm actually just like manually flipping this value. Because I don't do this on DirectX. And I wonder if that's the problem. I mean, it probably is. But the thing is, I know this works in a different scenario. So if this is the problem, that's going to be really annoying. But let's just try it and see what happens. Let's just get rid of that. My build system does that already. Like if I just like build, yeah, it does have a cache. I just clear the cache sometimes just to like be 100% certain. Just a habit. All right, so let me think. Yeah, I've had many problems in the past where the cache was actually the issue, and then it's like I'm chasing a bug that doesn't actually exist. Let's see, is that right? I think that's fine. If we recompile this. Oh, now I don't get anything. Okay. So maybe that wasn't the issue, which is actually a relief because I don't want that to be the problem. Just make sure that actually, yeah, okay. So let me just if-def this though, because I might want to check this again. I just, for the debugger, I just run the Visual Studio one, which actually doesn't work, so I'm not in debug mode. Okay, it's broken right now. If I'm like actually running the debugger, I'll either just use like the Visual Studio one or VS Code one, or I'll just run it with Visual Studio 2. Of course, my little button would be broken. This is a problem with my, oh, here we go. Continue. Yeah, it's just busted right now. I think I need to relaunch VS Code actually. What's this issue now? I didn't even touch this code. Why is this giving me a problem? What? Chunks equals null pointer init. Assert chunks is equal to null pointer. And it failed that somehow. I actually failed this one. Fluid, null pointer. Am I initializing a chunk twice? Oh, I'm not memory. I'm not clearing this. There we go. I think the debugger will work now. Yeah, here we go. Now I can like set a breakpoint here and just like, boom, there we go. So this is like good enough. I kind of hate the Visual Studio Code debugger though. It's not very good. It's like, you can do breakpoints and that's about it. And like get a call stack. Yeah, it's fine. You know, I just try to be so good that I don't need a debugger. Kidding. Yeah. I've also used the RAD debugger recently, which is really nice. I don't have it installed right now. But that's I like how like smooth that one is. All right, so let's go back to figuring out this issue. Man, it's so annoying when stuff works in one but not the other. Like, look at this. This works perfect here. Not a problem. I guess I have to look at the frame capture maybe. So let's render dock this. Like, what's odd is that it's working somewhat because it is like reading data from these textures. So it's just like there's one part of this that must be broken. So let me try and figure out which part that is again. It wasn't the collisions, right? I did test those. Those were fine. It's like either the collisions or the velocity is broken. And it's not the collisions. Well, it's not obviously the collisions. Oh, jeez. So it's one of these. It's like, is it this one? I know I just did this, but I have to do it again because I don't remember. So it's not that one. So is it this one? It's like, okay, now that was part of the problem because it looks different. So is it also this? I don't know. One of these is wrong. Like that looks a little bit better now too. But then the collisions don't work. So is it also the collisions? Is it just all of them? No, see, the collisions don't work. So if we keep the collisions on and then we try this one. Okay, so the collisions are fine. At least they appear to be fine. I don't think they're actually fully fine though, because the collisions aren't working vertically, which is interesting. Let's make sure that's actually accurate. And the worst is just doing graphics debugging in general. So I think inverse resolution. So this expects a value between, well, how am I using this? So I should change this from like UV to position or something, because UV is not what's actually happening. Or like index, I guess. I'll keep it position. So I'm just going to update this. Let's just get this working first. So position times, basically need this one. And then times the resolution divided by 2, so that gets us back into an XY. And then I think that should be fine. These need to be int 2. Interesting. I wonder if the water is actually like clipping into the blocks as well. So let's remove this. Yeah, it's just like missing the bottom piece. So how is that not correct? So this gets it back into UV space, 0 to 1, and then you multiply by that. Resolution divided by 2. And the collision texture is half the size of the other ones, right? Which draw call is it? This one? 512. Yeah, so that's half the size, which is fine. This is kind of fun. It looks like coral almost. Like those crazy fan corals. Or if I do like lava. Yeah, there we go. Alright, back to work. Let's see. I'm not sure why this doesn't work. That's so weird. It works in DirectX, right? In theory, they should be doing the exact same thing. Like, look. What I'm specifically looking at, so like on the underside of these blocks, you know, the water is like directly up to the block. But in OpenGL, for some reason, there's like an off by 1 happening with the vertical collisions, where they aren't doing that, which is really bizarre. And it just got stuck in the block. Okay, that's odd. Something's going on. I wonder if that's actually a collision problem, though, now that I think about it. Yeah, it is. But it could be the other stuff is broken, too. So maybe I should fix the other problem first before I spend too long. So P of a resolution, and those are to an int, X, Y, resolution. I guess one thing I didn't consider is, are these actually float 4 textures? Like, is that the problem? Like if I go in, because I think one of these is a 16. So if I just make this temporarily, it might be like trying to overread or something. Like do an unaligned read. I don't know if that looks any better. I don't think it does. Okay, that's probably not the problem. Here, I will be right back. All right, let's get back at this. Such a fun effect, though. So I'm gonna just isolate collisions from the problem. Let's just get the, oops, let's just get the motion fixed, and then the collisions will be next. All right, I think those are fine, but so let's see. Offset, that's scale 0 to 1. Resolution. So I could say it as an integer. So I'm not sure why that's broken, unless it's like not casting correctly or something. So let me make sure this is explicitly casting to an integer. Let's see. Right here. Okay, so that wasn't the problem, but let's just verify that this also wasn't the problem. Okay. And I should also verify that I'm actually sampling the correct textures too. Because that could be a very obvious dumb thing I'm doing too. So those are the same, those are the same. Zero, one. This should be. I'm not sure why I'm even doing this, because this will never modulo, so. So like it's that, and then I guess we can just make that that. And then that converts it to an int, x, y. Oh, I don't have space there. I need to look up the OpenGL spec on this function. Actually, something odd is happening. The texture coordinates at which to be sampled. So, seal texel. So what does this take in? A vector IVEC 2 x y. These aren't normalized though, are they? It's like hard to know what this should look like. Let's go back. Because to me they look pretty identical. Like that moves it out one. Be like one frame of simulation there. So they're just, it's like it almost works. There's just one part of this that is not working. Let's make sure these are using the sample functions. Let's go the other way. Let's first Hey, how's it going? You have joined at a fun time. I am hitting a graphics bug. And I can't figure out what the issue is, as usual. All right, so what's happening here? It's like I don't have precision or something. It's crazy. So this is at least fundamentally wrong. I swear it's just like off by 1. It's weird. Like maybe if I just -1 this, what happens? Maybe I +1 it. Yeah, look, it's like an off by 1 error. Yeah, I guess that does make sense, doesn't it? Because here I am in the shader code, flipping these values, right? Yeah, this is obviously an oversight, now that I think about it. Because in OpenGL, I have to flip the Y so it's consistent with DirectX. At least like, so my API is consistent with DirectX, because OpenGL, for some reason, just like flips all of the texture data, because it uses the bottom left corner as its origin, and then positive Y is like going up. Whereas DirectX is the opposite. Top left is the origin and positive Y goes down. So it's just like this annoying thing that 90% of the time you don't even have to think about it. But in this situation, I do have to think about it. And I was doing this in my shader code. It's a long story, but there's an off by 1, yeah, right here. I was doing this. So like this is the texture resolution, and I was subtracting by that. But obviously if you're like subtracting, you have to like -1 this, otherwise you'll get like an out of bounds read if you're like at exactly 0 on the Y. So that's annoying, but glad I figured that out. I guess as far as banging my head against the wall goes, that wasn't too bad. So I can just like -1 this. And we can probably get rid of this then. So now, I wonder if that's gonna break some of the other stuff I had though. Interesting. Let's see. Yeah. I guess, yeah, for more context, I support DirectX and OpenGL, and I'm working on doing Metal as well. It's kind of a work in progress. But I have like a kind of custom shader language that's meant to like bridge the gap. And I made this sort of out of my own laziness because I don't like rewriting shaders. So I have this little shader compiler thing that basically takes the shader I write. Jeez, I'm like lost in my code right now. Where am I going? I'm trying to show it. So like here's the shader for this fluid simulation. And this is in my own little shader language. And then this file gets basically parsed. And then if I'm running OpenGL, it creates like a GLSL from this, which is this one. And then if I switch to DirectX and I just rerun, this will get recompiled, and now it's a DirectX shader. So the cool thing is I can just like write shaders and they just, you know, I never have to think about, in theory, I never have to think about the underlying. Yeah, pretty much. It's like, it's like a full compiler, except like rather than generating bytecode, which you would like do in a normal compiler, I'm just generating either GLSL or HLSL. So like I have a full, like here's my parser, It's like this huge file that obviously just like parses the language, like tokenizes it, scans it, and then builds the syntax tree. And then like there's even a little optimizer, which I added this for dead code removal, which is kind of not necessary because like the OpenGL compiler will do this itself, but it's kind of fun. But yeah, so here's like the OpenGL output. So like in my shader language, where's the shader? Like I have this built-in function here called like texture. So like texture sample 2D is like sampling a 2D texture. So in OpenGL, you just do like texture sampler UV, but in DirectX, you have to do like texture dot sample. And I think you have to pass in the sampler or something like, it's like something like that, or it's like sampler dot sample. I don't remember. But yeah, so like GLSL, it's like, here we go. We generate this texture function here. HLSL, yeah, it generates the sampler thing here. So it's like way over engineered. I would not recommend doing this, but it is cool because it mostly works now, except for edge cases like this. But now it's fixed. Now I just have to turn the collisions back on. Let's see. Yeah, here we go. What do you mean they're both using GLSL? Oh, yeah. Yeah, I guess I can explain a little more. I'm not exactly following what you're saying, but it's just DirectX. It's like things are mostly the same between them, like the languages. The shader languages anyway. But internally, DirectX does some things differently than OpenGL. And some of this stuff you actually have to like think about when you're writing shader code. Yeah, I like here, I can just show part of the problem actually. So like if I launch RenderDoc and I take a capture of DirectX, and I look at like a texture here, like an input, like here's one. This is like the fluid, something or another for the fluid. So it's like, this is DirectX. So if I like right click so I can see the texture coordinates, and I go to the top left here. So this is in DirectX. The top left down here, like here, you can see it's 0, 0. Yeah. Yeah, so like, yeah, and OpenGL is going to be the opposite. And this is, I didn't run with RenderDoc. So if I do the same thing, OpenGL, just for like thoroughness. The top left here, so probably hard to see on the stream, but that's like 0, like 0.992. So it's flipped in OpenGL, and then RenderDoc as a tool like flips it back so it still looks the same. So it's like not even obvious that the coordinate system is flipped. But OpenGL has a function called texel fetch. This one, texel fetch. which basically it performs like, and it's like an array index. So rather than using like a normalized UV coordinate that's like range 0 to 1, you basically index the texture with like, you know, like a pixel index. So if you want to get the top left of the texture, like normally you would do like 0, 0, right? It's like your origin. So OpenGL would actually, the value that you would get from OpenGL would actually be the bottom left. So like if you have something at the top left and you're trying to sample the top left, if you don't know that OpenGL is flipping the textures on you, you could like be sampling from the bottom. So you'd have to like do 1 minus your, or I guess like the height of your texture minus the index, the Y index, to like get the right thing. But DirectX has a similar function called .load. So this does like the same thing basically. Because like all the languages, they do basically the same thing, except it's just that DirectX doesn't flip the textures. So like 0, 0 will actually get you the top left. So you don't have to do that like height minus in your shader code to like get the value you expect to get. But in my, it becomes a problem because in my shader language, I don't actually know, like the language doesn't know. Like when you're writing the language, you don't know what backend you're going to be using. So part of the compiler is like responsible for knowing when it has to flip these coordinates. So it's just like a little edge case you have to think about when you do something like this, because it's like, oh, OpenGL doesn't have the same, you know, coordinate system. So yeah, that's fun. You can store that away into like the back of your brain as something you hopefully never have to think about. But yeah, it's it's a pain in the ass, because I literally just spent, like, I don't know when you got here, but I spent like the last hour trying to figure that out. But now I can finally move on. So I think this works now. I don't know, maybe. Because the long-term, what I'm actually trying to do today is I have this water simulation thing I'm working on. And I have like this big simulation volume, which is like this square, you know, area. And it's just one render target that gets like simulated. So like, again, if I go back to the render doc and just like put a bunch of water in here, and I like take capture of this. So like this whole simulation volume is just one like render target, or there's a couple of them because I need to store some extra data, but like it's just like one texture, and basically it flip-flops between draw calls as it's like simulating the motion of the water. But my game is broken up in chunks. So this is the game I'm working on as well. Let me launch this. So I'm basically making a Terraria clone. And I'm going to add the water to this eventually. It's a work in progress. But this game is like, the world is broken up into chunks. And the chunks aren't guaranteed to be loaded in like a rectangle around the view, because like, I mean, like that's like kind of like the naive way of doing it. Like if you play Minecraft, you know how like the world just loads up like around you in a giant square or a circle. That's kind of like the naive way to do that, but I want to like, since I'm a 2D game, I don't need to like load everything super far away, or like in a square, right? Because like you can only see within the view. So I'm going to be loading chunks that like actually span the surface of the world, so I can have more of the world itself loaded rather than like loading chunks in the sky. So currently my simulation just works on a square, basically. But I actually need the simulation to be able to work like with any sort of shape arrangement of these chunks. If that makes any sense. So like, it may be hard to see, but I have like these little lines. So these are the chunk boundaries. And I need to change my code so it doesn't assume that the volume is actually a square. Yeah, because otherwise it's like half of your, if you're just on the surface, half of your water simulation is like trying to simulate sky. Not saying water can't be in the sky, but the system shouldn't be like forced to load sky. It should be able to like divvy up these chunks in a more, I don't know, efficient manner. So I'm kind of working on, or I'm going to start working on that. And this will make multiplayer easier too. Yeah. Basically what I'm after is that, so I'll still have like a single square here because like that's like the shape of a texture is a square. But I'm gonna like divvy up the square just into chunks, so that like you'll see a square like if you like open up RenderDoc and just inspect the texture, but each chunk will like be sort of simulating its own little independent slice of the world. And I can like assign chunks within the simulation like square, I guess, to like represent different chunks in the world. Just so like as I load in chunks that are like in random places, they can still have like water simulating in them. They'll just end up like somewhere in this simulation volume will be assigned to that chunk. That's the premise, at least. I don't actually know if this is gonna work because I don't know, I've never done it before. In theory, it should be fine. Like, I think I can get it to work. The tricky thing is I have to think about like what happens when liquid travels over like chunk boundaries. Because if I just like naively break the, yeah. Like, I don't know, I'm just kind of like testing it out. There is a solution to this problem. It might be this one, it might not be. But I'm gonna try it out. So we'll see. But yeah, like right now, so like the water, basically the way the simulation works is the water sort of like knows about its previous state from the last like update tick, and it knows about all its neighbors. And from that, it can calculate what its like next state will be. Kind of like, it's like cellular automata, where it kind of just like can figure out its next state based on like the current state and its previous state. But part of that is it has to know what like the neighboring water particles are doing. And at chunk boundaries, it's gonna have to like know which chunk is to the side of it. But if I'm no longer like divvying up this simulation such that like the neighboring chunk is actually to like the side, it's gonna need to like figure out, okay, like which chunk is actually to like the right or the left of the current chunk. So there's like a mapping that's gonna have to happen at the chunk boundary so it can still like sample the correct water. Again, I'm just rambling again. But I don't know, we'll see. I'm kind of procrastinating too. But first thing we need to do is actually divvy up the world into chunks that have, it's all in the GPU. So it's done in two shaders that sort of flip-flop back between them, like back between each other. So there's like there's one shader pass that treats the water like basically particles. So like each water has like a mass, a velocity, and a position, and a pressure. So it has like those 4 parameters. So like one pass simulates the water as particles, and that's how it can like interact and contribute mass to like neighbor particles. And then there's another pass that basically takes that and so there's another pass that takes that and then puts it back onto a grid. And this is like just one method of simulating water. It's like a popular one. I think it's called FLIP, F-L-I-P, which stands for something. It's like that's, and the cool thing is like you get this sort of particle-like behavior of the water without actually simulating particles because it's all based on a grid. So it's kind of cool. So like you can have just like a huge amount of water without much cost. And it's cool because it like there's like I can do like mixing of different fluid types too. Oh, I gotta get water. It's gonna do the fountain. My favorite is the fountain. Fountain. It's such a hard word to say. You do a little water fountain. I can like picture a fun mechanic in the game. So I have oil is one of my liquids. Because I want to be able to like add an oil drilling mechanic. And I can just like picture a fun like oil drilling sequence where it like shoots the oil up into the air. Yeah. Yeah, no, I literally just grinded this out for like 2 weeks. Like I have never done water simulation before, so like I really just grinded this out for 2 weeks. And I like loosely followed some paper and some existing work. So I don't know. My simulation is like a mix between, I don't know, a proper simulation and also kind of just like finding magic values that made it look good. So I don't know, but I'm really proud with how it turned out because I wasn't actually sure it was going to work. And like I wasn't even sure I was going to be able to do multiple liquids that like interact with each other because it wasn't obvious to me that that was going to be possible with this technique. But it turned out just changing the viscosities of like the fluid types actually just does this cool behavior. So I'm excited to get this in the game because I think it's going to look awesome. But I need to get this also like working efficiently, like outside of this little testbed project. So yeah, I need to do this chunking thing. So let's do this. I'm not even sure where to start. Yeah. Like I know I'm kind of making a Terraria clone, which is it's not actually a Terraria clone. The gameplay is going to be a lot different, but visually, you know, it's like hard to escape the Terraria clone thing. But I can make myself somewhat unique by having cool water physics. So I think that's fun at least. I don't know. I think it'd be fun to be able to like have giant waves and stuff. Like I have a cool idea for like the beach biome, because I can just add velocity to the fluid, and it makes like actually kind of realistic looking wave effects too. Maybe there's too much speed here, but you kind of actually get like the rolling cascades of the waves. So for the beach biome with the ocean, like I think I'm gonna actually try and get like the waves to form on the surface and crash against the shoreline. I have an idea how I can make that happen. So I don't know. I like want to get this in the game so I can start playing with it. But we need to we need to grind through some of this stuff first. So let's see. So I need a way of assigning chunks to be part of the simulation. All right, let's see. So I just did a little speed run of a chunk system in this little project. Let's see if the get chunk works. Let's also draw the ID. All right, yeah, sounds good. Yeah, it's fine. It's fine derailing. I'm just proud I fixed that bug recently, just before. Yeah, sometimes I just get in the zone and I stop talking too, so it's good to have some moments where I talk a bit. Let's see. Interesting. I need a way of like breaking up. I think. So like what I need to do first is like generate a mask for this like simulation volume. So basically each here, let me think. So like each chunk knows which chunk it actually is. Because like right now I'm just rendering a quad and that's what I'm using for the shader. But I need to actually be a little more fine tune the quad. So let's see. Um, yeah, I mainly just do that because I'm always like committing to the source, because I work on two computers a lot of the time. I have like a laptop I work away from home with. So I think it'd be kind of annoying if I'm just like constantly just spamming work in progress stuff to like the main repository. So yeah, I should get in a better habit of actually updating the one that's there. The one that's there is meant to be more of like a version I know is like working and in a good state. If that makes sense. But yeah, I'm not really... all the sources out there. I'm probably going to keep the games I make more closed source, just because like I might have commercial aspirations for the games themselves. But I don't have any like commercial aspirations for the engine, so I don't care if people look at it and just download the code or whatever. Nothing I'm doing is like proprietary, so yeah. It's kind of the thing, like I wish there were more code bases out there that were doing some of the stuff I'm doing. So like, maybe I should be the change I want to see in the world. I think like a fully open source game engine would be cool. I just don't have like the time or the will to actually do that myself. So it's like I kind of just want to like make games too. I don't really want to be maintaining an engine in like an open source capacity. Yeah. Yeah, I should do that. Do something like that too. Yeah, it's just like in general, like there's just like so much that goes into game engines, obviously. And like I know the things I need for the games like I'm working on. But like if you make an open source engine, you kind of have to like think about the games other people are working on. So whereas I might be like, oh, I'll just do this later. Like that could get really annoying to somebody if they like actually need a feature that you're working on. So yeah, that just becomes a full-time job just doing that. And I don't know. Maybe someday. My thought is maybe after I make some of my own games in the engine first, it'll like kind of force the engine to be like get to a more mature state. And like at that point there might be something there to like think about, I don't know, making more public. Yeah, exactly. It's like I already have a full-time job. Like I do software dev as like my main job, and I just sort of do this stuff for fun on the side. And ideally I'd like to keep it for fun on the side. And like I don't think I can make a paid game engine. Like I don't know. I don't know if people really want to pay for that. Like I guess it works for like Unreal and Unity and maybe Game Maker, but I don't know. It just seems like turning it into a business is a lot to chew. All right, so let's see. And I mean, like, ultimately, what's my sales pitch too for my engine? Like, I'm just kind of, again, I'm doing it just for fun. I'm not like inventing anything really novel here. Like, the main thing I might have going for me is the compile times. Yeah, exactly. It's, yeah, like there are many good engines out there too. Like I'm not, some people get really passionate about like hating on, you know, the bigger game engines out there. Like I used Game Maker for like 10 years. So like I don't have any like major qualms with existing engines. I'm not a big fan of like Unreal and Unity just because I feel like there's a lot of like extra cruft in those engines that I don't need for my projects. But I don't know. It's like I could make Vitality in Godot probably if I wanted to. It's just not fun for me, I guess. Like I want to have fun doing what I'm doing. But yeah, that's my that's my general spiel on that. All right, so let's see. This is the update function. I can't think straight right now. All good. All good. But yeah, it'd be cool if Vitality... Well, one, I need to actually finish this project because I've been like working on this thing on and off for who knows how long. I think I'm more disciplined now, though, than I used to be about actually getting things done. So there's like a small sliver of hope I actually finish this in some capacity. That's the dream. All right, so let's see. Okay, that does not work. Okay, so ideally I get a shape in the screen somewhere. Needs to be drawn down here. Okay, now the harder part. I need to think about how the shader needs to change now. Oh wait, this should be... So like the difficult part is actually just this mapping in the inner loop, because this is the part that can cross chunk boundaries. So I need to handle that somehow. And the collisions, I guess, can also cross chunk boundaries. Yeah, it's really fun to play with. I end up spending so much time just like messing around with it. It's kind of like those like particle games, if you've ever played those. Like Particle Toy, I think is one of them. It was like a classic. It's kind of like that. What's cool is going to be the volcanoes as well, because you can do like the sort of bubbling lava effect at the surface of the lava. Oh yeah, maybe Powder Toy I was thinking of. I have so many ideas of what I can do with the liquid in the actual game. It's gonna be super fun. I'm excited to work on it. I'm not excited for getting it to work with multiplayer though. But we'll cross that bridge when we get there. All right, so I need like, so basically what I just did is I have these chunks now, and when I press Q, I'm like assigning a chunk to be simulated. So what's happening on the top left here is I'm generating a mask, essentially. So this little shape that's generating, and if I press E, I can like remove chunks from the list. So like these little slots, it's like basically creating a square, which I'm going to be using as my mask. So when I do the render pass for the simulation, I'm going to render this mask instead of just a giant square like I'm doing currently. So that way only the chunks that are actually like active will be simulated. But this introduces a new problem where like this chunk ID 18 is like next to 19 here, but it's also next to 26 now. So like any fluid that would be on the border between like 18 and whatever's next to it is no longer guaranteed to actually like be like one pixel over or like texel over in texture space. So I'm trying to think of like how I can map those UVs. So like if it detects that it's crossed the chunk boundary, it's gonna have to like look up where it actually needs to go to sample the texture, which is kind of confusing to think about. So I'm kind of just sitting here thinking, I'm gonna need some sort of table. Yeah. I'm gonna need to create like a table that I can look at and then see like, okay, this UV actually means to like index this specific chunk. So I just need to think about like what that actually looks like. And each chunk only has 9, or I guess 8 neighbor chunks. So 9 including itself. So it's like, I'm not even sure what that table would look like. This is tough. It's actually tough. I think I just need to write like a little CPU function that I can just figure this out first and foremost. So let's just see. Let's just draw a box. So like static UV equals. So we have a UV coordinate. And then if that UV goes negative, that means it's in the chunk to the left. If it goes positive, it's in the chunk to the right. And if it's between 0 and 1, then it's just like in the current chunk. I was trying to think if there's an efficient way of doing this, because this can't be, this is going to be happening a lot, like a lot of times, because each particle has to do this 9 times. So I have to like have an efficient way of actually figuring this out. So let's see. If you convert a negative, I should know this. Like if I have a negative floating point value and I cast it to an int, what actually happens? Does it round up or down? Because I might be able to exploit this. So like if we have negative 0.5, what happens? 0, yeah, it goes up. But if you have 1.5, it goes down. So I guess you can figure out like which cell you're in if you take basically 1 plus the UV and then you cast it to an integer. You'll get a value either 0, 1, or 2, which and then you just do that for both axes. 1, 2. Yeah, and then your index into a table would be like, let's see. Let's see. So this should be 5. I think 4. 0, 1, 2, 3, 4. Yeah, okay, that makes sense. So if I have a point like 1.5, 1.5, that should be, I think, 8. Yeah. Okay, so that's pretty efficient actually. Because what is that, just a cast and an addition and a multiply. Yeah, because then from this, I can have like a table of, let me think. I guess I would have 2 tables, or just 1. I think you're better off doing 2 tables. So it's like, it's like a U map and a V map. This is an array with, I don't know, however many chunks you have, like 64 of these, and then 3 deep, maybe. So if I need to get like my actual UV, it's just a matter of doing something like, what happens if I get the modulo of a negative UV? I forget how that works. What's the issue? Fmod. I guess I need to get the fractional part of that. Okay, yeah, I think this'll work actually. Not sure why not. I guess this would also be lives. This doesn't solve what happens if a chunk doesn't actually exist, though. So maybe this needs to be like a... be like a map of neighboring chunks. For each chunk. And then we can just index that chunk's UVs. So like chunk UV, I guess. From that. All right, let's just start writing. Let's make this a big number for now. It is annoying how there's 9 instead of 8, because that just makes the alignment really bad. Like 2,000 bytes. 2 kilobytes. Oh well. Okay, I think this function should work in theory. Now I just have to fill out the data for it and then update literally everything else. I'm gonna call something else like yeah, I did do that. Essentially. Yeah. I spoke about it a bit earlier today. But yeah, I have this like common language that I wrote to like reduce the amount of code duplication between the graphics APIs. So that's why it looks kind of weird. Yeah, it was a project. It was fun. It was fun. I'm still working on it too. I'm currently working on implementing Metal API for Mac, and I have to get Vulkan in too at some point. So it's a work in progress. Vulkan's nice because you can just use SPIR-V. So I can just like write a GLSL shader and then translate from that, which is really nice. Yeah, my brain is just not working right now. All right. I'm working on this crazy mapping for my fluid simulation. So I can get UVs to like index the right part of the texture based on a chunk system, while also doing it in like an efficient manner. I really don't like how this is 9 deep. It's really annoying. And I guess I don't need to use integers here either, but that's fine. Okay, let's just start filling in data. It's the next step for this, I think. Just trying to think of what I even need. Just make sure this compiles. But yeah, I can show that off really quick. The transpiler. Yeah, so basically I write the shaders in my little .shader language. And then depending on the backend I'm running, in this case I was doing OpenGL, I can actually like look at the source code that's being generated. So like here is the simulation shader in like generated GLSL code. And it looks kind of crazy because I have to like prefix stuff to avoid like namespace conflicts essentially. But if I like switch to DirectX and I just recompile, and DirectX doesn't recompile, it's funny. Let's figure out why that is. Conflicts with existing type. Oh, I renamed the same thing. Let me fix that. Yeah, that was just an issue on my part. Let's fix that. Where is this? Chunks. Call this like chunks or something. Missing semicolon. Now it's just mad. I need to make this what's 256 times 9? 2304. Yeah, so that was DirectX. So you can see the DirectX version of that code. It's actually not that complicated. It just like sounds harder than it is, I think. It's just a lot of work, really. That's like the crux of it. It's just a grind. I enjoy the grind though, so it's fine. But it's definitely a grind. All right. So let's go back to this. And the cool thing is, so I just declared these, this C buffer, I call it, these things. So these are like uniform buffers, or like a constant buffer, or a structured buffer if you're used to like DirectX lingo. So like I just like define these here. But now, because I have this as part of my build system, the compiler, I can just immediately access that like in my C++ code from the CPU. So like now I can just go to this, here it is, like here's our, okay, it's actually not in here, I need to recompile. Here I am showing you something that doesn't even work. Classic. Or my IntelliSense is broken, maybe. What's happening? Let me restart my IntelliSense. It's not in here. Okay, interesting. Should be in there. Oh no. All right, well, we have some issues, apparently. It's not in there. Oh, it's because I'm not using this function anywhere. So yeah, it's just getting compiled out. Yeah, I have this like an optimizer pass on it too. So like I'm outsmarted by my own optimizer here. Let's just like add this to the shader somewhere. I don't know. Yeah, so now it should show up. Yeah, here we go. Yeah, so now I have just access to this this buffer straight away, which is cool. And then I can just like write to it however I want. So I actually need to write to it here, I think. And I'm trying to think the best way of actually doing this. Because there's a lot of like odd edge cases I need to think about. Yeah, I could talk about this for a while because I thought about this really deeply. It's so annoying. Like, my biggest gripe with graphics programming is it's like there's like a million ways to do the same thing. And then you have like Apple over there off on the side that are like, they just say like, oh, screw OpenGL and screw Vulkan. We're just going to do our own. It's like, do we really need another graphics API? But then if you wanted to like do like iOS, like if I want to get this game on iPhone, it's like, well, I basically have to do Metal, right? Because I think you can use some old deprecated OpenGL version. And that's what I have been using for my, I have this working on Mac too, this engine, but it uses OpenGL 3. And it's just like a pain in the ass. It's like, I already hate thinking about graphics code as is, like most of the time. And then to think like, oh, there's like all these different ways you can do stuff. And then there's Vulkan too. I haven't done Vulkan yet. I'm gonna do that sometime. I don't know. I'll just go be mad. I'll go cope harder. Yeah, fun times. Okay, I need to visualize this buffer or something. Or I just need to fill it out. Let's just do this. So like generate shader chunk map Being buffer. Well, they all do. So you can do the exact same stuff in every one of them, right? Because like ultimately they just talk to your graphics card. And your graphics card has fixed hardware that does like specific operations. The difference is just how you actually go about doing those things. So like OpenGL is like the easy one because essentially it's just like a simple state machine. You just have OpenGL functions that set state, and you just think of it like a giant state machine. DirectX is kind of similar, but you have to be more explicit about things like setting up like descriptors for like I don't know. I can just show some of the code briefly, just like what the difference is between the two. And I'm using DirectX 11 too, so it gets a little more intense in DirectX 12. But I'll go on a little tangent while I think about this buffer stuff in the background. So let's go to the graphics. So like creating a texture on OpenGL. I think it's like texture 2D init is my function. It's like this much code. The rest of this is just like debug stuff. But it's like essentially these calls, right? Pretty simple. You set like, okay, you have to bind a texture to the state machine so it knows like what texture to create or like to apply these settings to. Then you set some like texture sampling parameters, like what happens if you sample off the edge. And then you just give it pixel data and like a width and a height and like a format. And boom, you have a texture on OpenGL. But then DirectX, same function. It's actually pretty simple on DirectX 11 too. But like, instead of just having a function that takes in all of those parameters like this, you instead set up these little descriptor structs, I guess they're called. I'm not like description structs. So it's like rather than filling them out as function parameters, you just like fill out this struct. This is just a struct. And then filling it out. And then you just pass that struct to the function. So like they all do the same stuff. It's just a different way of doing it. But Vulkan is like significantly more verbose than even this. And yeah, I have heard of Manta and VK. It's an option. Like I personally I'm just gonna do metal because I think it's just worthwhile to do it, at least. I don't know. It makes me a better programmer, I suppose, if I just kind of do it, but yeah. It's just like I'm sick of it at this point. So I don't know. Okay, so let's see. I need to fill out basically this buffer with some data. Let's go, where is it? This thing. So what does this actually look like? So I'm not sure what to actually store in this so like I guess if I'm trying to think. These like obscure little mapping table things are always a pain to visualize. Okay, so I just need like store chunks. So this should be easy. Let's start with the easy ones, the bottom ones. So each chunk has just its own. So gfx cbuffers dot chunk map dot chunk u. So this is just how far into the simulation volume is this thing, which in this case is just it's the ID. Do I have a helper for this? Chunk size. Okay, so it's like the so it's like that divided by, so let's see, like, I just need better macros. Because I need this as like a variable that I'm going to reuse a lot. So like, that's that. So that divided by that. Yep, that makes sense. So then the chunk's position within that is simply that, and then this is a UV coordinate, so we need to divide that. And then the V is also pretty much the same. So this is our table of, basically, if you have a chunk ID, you can find out what UV that chunk actually like sits in within the simulation. So now we need to make the map between the simulation ID to a chunk ID. So okay. Sometimes when I write code like this, I just like, my brain kind of just stops being conscious and I just like let my fingers go. And then I just trust the process. So this is that. So if that is less than 0, then this chunk actually isn't doing anything. So we'll just fill it with nothing. Yeah, I think that's correct. We'll set these as negative values too, so we know. Otherwise, this chunk is being simulated, so now we need to find whether any of its neighbors are being simulated. What do you mean a script language? That can mean a lot of things. It can mean a lot of things. All right. So for this is our chunk. So let's see. That is just this, I think. And then I need like a lambda or something in here just for like. Oh yeah, yeah. So yeah, there's also an object script thing. Yeah, I forgot about that. Yeah, I have this, it's just a really complicated little system, but it's really fun once it actually like works. I can explain that in a second, but let me just reason through this first. I'm just trying to, it's really hard to visualize what's happening. Also, why is this not showing up? Oh yeah, duh. So what is I here? It's chunk IDs, and then so I have like two different things going on. I have like a mapping of actual IDs, and then I have a mapping of simulation IDs. Wait, actually this isn't too bad now that I think about it. Okay, so this is just get chunk. It's like x equals that divided by that. And that divided by that. This sort of thing's annoying to do as well because I can't actually like see if it works until I've written all this code. Because it's like, it's hard to test something like this in an intermediate state. +1, +1, +1. And then dot simulation ID. And for consistency's sake, I guess I should just do this too. Now this actually won't work because at the edges, it's going to, it's gonna segmentation fault. So I need to wrap this as a as a lambda or something for now. What's the syntax? It's like int? Is this right? Yeah, sure. Actually, let me just make a function for this. I just program a lot. I know that's a horrible answer to that question. I did, for a while, I worked at a AAA company too, working on the engine for, yeah, AAA games. So like, I was exposed to a lot of like lower level game engine stuff just at my job. So like some of the patterns I use now, I just sort of adopted from that, I guess. I don't work in AAA anymore. I work at a different job. Still programming, just not in the games industry. But I still really like doing game stuff, so I do it for fun. Otherwise, we just return this. And we can just simplify this. A lot of the code I'm writing now, I'm gonna come through and actually like clean up too, because this is like not very good. Not very good code. It's just kind of like, oops. I'm just trying to get something to work so I have like somewhere to start. And then why doesn't, yeah. Okay, so I need a way of visualizing all of this now. So let's just draw stuff. Okay. So if I initialize this, I immediately hit an assertion. Nice. Where was this? I love when the first thing I do just immediately breaks. Oh, it should be that and that. Or, greater than equal to. Yeah, that should have been fine. Oh, this should be -1, should they? Okay, here we go. Okay, so I have too much stuff drawing. I love when I just fill the screen with a bunch of debug garbage that's just impossible to read. Let's just shift this over. It's still too much. Okay, so that's already wrong. I think. Oh, maybe not. One, two, three, four, five, 6, 7, 8, 9. Okay, what'd I do wrong? I'm pretty sure that was wrong. Zero, 1, 2, 3, 4, 5, 6, 7, 8. Maybe 1, 0, 1. That should have been fine. Chunk X, chunk Y. What I expected to see when I pressed Q is that this 0, or this one in the parentheses, should have been 0, not the one over. And then this one should be 1, 2. It's like it works, but it's just 1 off, interestingly enough. Or maybe, no, maybe that is right. I think that is right. I just messed up my print. So maybe it did work right away. I'm gonna cluster these just so it's even more obvious. I'm just writing like kind of pseudocode right now. Because I'm actually not sure fully what I'm doing. I'm gonna come through and clean this up at a future point. Right now I'm just like getting it to work, and it's just easy to write kind of rough code. Okay, so I think this works now actually though. I don't know where those chunks were. I need to make them visualize or something. 24. So if I come here, if I do this whole row, and then I delete the first chunk, and then maybe do this chunk. So the first chunk in here is 15. Let's see. So I guess the second chunk, yeah, it's chunk to the left is -1. So then if I come and reinitialize this, yeah, it's 8. Okay, I think this works. But yeah, normally I would use a const function. I think in this specific case, I'm not sure which function you were looking at. I'm not sure if the function I just wrote can be const though, const expr. Because it's sort of a thing that changes dynamically at runtime. So I can delete all this stuff too. Why is this in here? I don't need any of that. All right, so yeah, you probably, I had some debug stuff in there from earlier. I was just kind of like drafting ideas as in code. Okay, now let's do the next part of this. So I have this mapping. I don't know what's happening here. And the water's so fun to play with. Okay, so I have this mask. I need to actually change the UVs that it uses though. So let's see. Chunks. And this should be its own function too eventually. And let's see. Yeah, that's fine. So this needs to actually be a quad. How big is a chunk relative? It's always 128, I believe. Okay, so oh, I just lost my screen for some reason. I don't know why that just happened. 1 second. I'll try to fix the screen. It's odd. There we go. Should be back. Sometimes I think like my capture card overheats or something. All right. Eventually I'm going to use a special vertex buffer for this, but for now I'm just going to kind of pack values into the color values, I guess. So So it has that, and then just that, I guess. And then we draw this instead. I don't know what's happening. I always forget I'm streaming on Twitch as well. How's it going? I don't know where everyone just came from. Nice. Sweet. Cool. Well, welcome everybody. Welcome everybody. Hopefully, what I'm doing is interesting. I don't know. I'm just over here filling buffers with data and hoping stuff happens. And I can get rid of this. Yeah. Me, no I'm not. I graduated about 4 years ago. Yeah, working on water. It's gonna be sick. Yeah. I'm working on so I have the simulation working now. This has been like a 2-week project for me. So I have this water simulation that I'm gonna be adding to my game soon. Yeah. So there's different liquid types and stuff, which is fun. Right now, specifically, I'm working on updating the simulation code so it uses like a chunk-based system rather than just like a fixed rectangular volume. And then after that, I'm gonna be able to get it tied into the game. So it's just it's a work in progress. It's pretty tough. I'll say that. It's a project. So like I have a bunch of debug stuff drawing on the screen right now because I'm just trying to figure out how to basically break this into chunks. But yeah, I just started this game. Well, restarted it, I guess, early last month. So this is the game itself right now. There's nothing to it, but it's essentially it's a Terraria clone. And I'm gonna get the water in here soon. It will. Once I get it in the game itself, yeah. What's cool is last week I added stained glass for like lights. So this is fun. I'm gonna show this off. You can put stained glass and like get red light, which is fun. Yeah. You can make it nighttime too. So yeah, I started this about a month ago, so I'm kind of just grinding through it. Place like different lights down. The actual gameplay will be different from Terraria. Like it just looks like Terraria, so I just embrace the Terraria clone thing because it's fun. But I'm working on the fluid simulation. So I actually have to break this into 2 functions. And what's sad is I'm about to just break all of this once I start transitioning this code over. So I'm trying to do as much as I can before I start breaking stuff. So I can delete that. So we'll like update chunk map buffer. And I'm gonna need to render doc this too soon. So in theory, as I start just transitioning this render pass stuff, I have to just like replace these functions, these draw quads, with my new function I just wrote. Let's see, what else do I have to do? Oh, those are the wrong ones. I did computer science. Where's the simulate function? Here it is. I have DirectX and OpenGL in the engine currently. Right now I'm running with DirectX, but I can switch between them. Okay, so I think those are all of them. Yeah, so now it doesn't do anything. Because now, yeah, I've been procrastinating doing Vulkan. I'm actually in the process of getting Metal in for Mac and iOS. Well, I say I'm in progress. I can like work on it for like a couple hours and then I stop for a week. But that's coming eventually. Mostly because I want to do iOS as like a build target for this, and Android. So I'm gonna do Vulkan eventually, but it's just Apple doesn't support. Yeah, Apple doesn't support OpenGL beyond like 3 point something, or maybe it's 4.1. And there's features I want to use that are newer than that version. So, okay, now we have to fix. Let me render doc this actually. Oops, this isn't going to do anything. Yeah, it's because they're crazy. It's insanity. It's insane. Okay, so we have a chunk mask. All right, let's see. I guess what I really care about is what does my mesh look like? That doesn't look right. Okay, so output. I think I missed an update step. I have to change my frame rate. Yeah, so like I just broke the water, so it's gonna be a while before it looks cool again. Unfortunately. Oh, I didn't capture. Here we go. So now this should look, yeah, like that. And then what are the color values for these? Yeah. I need to break it before I can fix it. That's basically how it goes. And I'm not actually uploading the buffer either. So a few things to do. Let's see. I get like lost in my own code too. So buffer. So we upload that, and then I guess I can just come in here and start changing these. Okay, so it's the only place I sample a texture in this function. This is just a matter of, man, this is tough. Okay, let's see. Yeah, I noticed that. The Twitch one doesn't show up. I have no idea how many people are on there. Yeah, because I have this like multi-stream thing going on where I do my YouTube channel and Twitch at the same time. Twitch actually has higher quality. It takes like a better upload speed or something. It looks way better on Twitch than YouTube. Okay, I need to think. I'm like transforming like UV spaces a lot here. And it should all work out. I just need to really just buckle down here. So it takes in the input. Let's do this on a new line so I'm not confused. Let's do this like here. So it takes the in UV. The offset is this times 1/128, which is a crazy number. And then the chunk is the yeah. And then we need to take in this too. Such a long line of code. And then last but not least, we need to multiply this by resolution. And I think that should work. And yeah, you pass in this. Okay, we're seeing something again, which is a good sign. Not quite what we want to see, but we see something, which is always a good sign. This needs to return something if this fails, though. Yeah. So I just need to change, basically I need to copy this in a couple places. This itself should just be a function, honestly. But for now, we'll just copy and paste. Because I do this a few times. Like I do this here as well. So it's like... do that there. And then up here as well. This might look somewhat better. Okay, not quite. Let's turn off the collisions as well. No, this isn't Unity. This is my own game engine, actually. You just joined as I broke, as I'm in the process of dissecting the simulation and fixing some stuff. So that's fun. Let me think. I need to think here. I actually think that should have worked. This should be working again, in theory. So something isn't working correctly. Let's see. Index. Yeah, the sad thing is you can't print from a shader. So it's just like, good luck, GG. It's hard to know where the issue could be as well. Yeah, exactly. I mean, I know, oh wait, it just started doing something. It's hard to see what's happening. Let me render doc this. Maybe that's more insightful. This should have started working again, in theory. Unless... No, it should be working. It's possible the buffer has nothing in it as well, so... Yeah, so it has the color. No, the simulation's just broken. Here, I can. I don't know if you saw it before. I have a working version as an exe somewhere. This is what it looks like before I broke it. It's pretty cool, actually. And there's different liquid types too, so you can like mix oil with the water. And there's lava as well. And I might add another one, I'm not sure yet. But it's cool, you can do like a little fountain thing. Let me block off this. So there's like a little fountain. It's kind of fun. I'm looking forward to doing the oil drilling mechanic, where like you get the classic oil. No, this isn't fixed. This is a an exe from like an hour ago. I just wanted to show it off because someone asked. No, it's still broken. I wish it was fixed. Let's see. What could possibly be wrong here? It's the question of the hour. I really just need to print some values out, I think. So let's just do that. Let's just debug, draw some values. Let's draw the X value of the UV into this channel of the texture. We need to add that as well. I like moved some of my code around too, so I like keep getting lost. That shouldn't be needed because it's accounted for in that function. I actually want the goal is I shouldn't need to use the modulo. AI stuff, I don't really use it in the editor. I would lie if I say I don't use ChatGPT for like inspiration sometimes. Yeah. Well, okay, I can explain that. So Manta is the name of the game engine. Vitality is the game. And in VS Code Untitled is just, yeah, it's just an Untitled. Yeah, because Manta is like the engine. So I have multiple projects in this engine. So like this one is a little voxel demo. This isn't actually a game. This is just a little renderer with shadows. I wanted to see what voxels look like with vertex shadows instead of like fragment shadows. So the game engine can make multiple games. I have like a chess thing in here too somewhere. I don't know if this compiles still though. Might have broken this. Yeah, this one's broken. So yeah, I'm kind of like making the game engine and the game. Oh, I just bumped my mic at the same time. All right, so what I break? Oh yeah, I don't have an offset, so this should be. Okay, this should be. Yeah, thanks. Hey, how's it been? Long time no see. I thought the name was familiar. So many people pop in and out. It's like, sometimes I miss people. Yeah, I'm doing good. I'm doing good. I'm working on some fun water stuff right now. Still doing game stuff. It's fun. All right, let's see. One of these should have. Yeah, I kind of started the streaming stuff just as like a, I don't know. I thought it'd be interesting. It helps keep me focused because I can't like goof off when the live stream's going. And sometimes I need that. Where is the output for this? One of these is the right one. This one? I think I missed it. Yeah, exactly. Yeah. I can't go like scroll YouTube or something. And especially like right now, I'm working through something I actually like have been procrastinating for a while. So it's even if no one watches, it's still like I'm on video goofing off. I'm so confused. Which one of these is the 16? It's like it's not even doing anything. Is that the problem? One of these should be a... All right, let's see. That one is not the right one. That one is not the right one. this one? Nope. Okay, here we go. Looking for this one this whole time. Okay, I think the problem is obvious now. So these shouldn't look the same, all four of these little squares. Yeah, that's actually a good call out. So we have like 0 to 1 and then it pops back to 0. Okay, so the function's just not actually working. Should be obvious. So what's the issue? This part works and this part works. So the issue is it's not getting anything from this. Let's see. So like this is returning nothing. Yeah, that's basically what I just did here. I'm just like printing the value of that function. So like in this case, let's do another little example. So when I press Q, let's run with render doc, I'm like activating the chunks that my mouse is at. So like these top 5 chunks are active now. So if I had liquid to them, and then F12 to get capture. So what I expect is that the blue channel over here is supposed to be like the mapped UV coordinate. So these should be a continuous spectrum right now, if this was working correctly. But they're not, it's just like it's just copy, like duplicate of each other. Which tells me it's not actually getting the chunk position correctly from the buffer. So if I hard code some stuff here instead, so if I just do like, if I just pass it chunk like 3, let's just see what happens. Something along the line here isn't getting any data. No, I lost my draw call. There's like nothing happening in this frame. And sometimes I grab frames where nothing's happening because I have like a scheduler going on. So let's try this again. Yeah, okay, so I don't think there's any data being uploaded here. So maybe, and then the next trick is you have to check if that's like a DirectX problem or if that's just a, an actual just issue with the code. Because sometimes these issues are like based on how the API expects things to be. Oops. Like here, it's also broken, so that kind of tells me that nothing's being uploaded. So maybe I just need to explicitly upload these. Where's the simulate task? Let's just ensure that these are actually being uploaded. It probably will, I believe you. Debug. Oh, I just put this in the wrong spot again. Where is the simulate task? Here it is. I believe you. Sometimes I'm not very efficient with my navigation. All right, let's see. Let's see if this is any better. All right. No, it's not any better. Is it uploading the buffer though? Yeah, it is on map. That looks about right. Buffer 90? Or 91 maybe? No, 90. Actually, it's hard to tell. Is that correct? Let's see. So 256 times 9, 256 plus 256 times 4. Yeah, this is the right one. Yeah, essentially is what's happening. Is it possible to see like the actual data in here? Offset. Like it's getting the data. So I don't think that's the problem. Just to be entirely sure. Let's generate this every frame that this happens. Yeah, I think GPT would probably send me further awry than I already am. Let's see. Yeah. I feel like ChatGPT has gotten worse over time. I don't know if it's just me. Maybe I'm using the wrong model for it, but it used to be pretty good, and now like nowadays it's gotten bad. It's like I almost just stop using it. Yeah. I don't keep up with it too much. Yeah, I should try that out. I try not to use AI too much, but yeah, it is really helpful sometimes. All right, so let's think. What could possibly be going wrong? It's definitely this that's broken. Something here is broken. And I guess I never did test whether those values are actually correct. So let me print those out too while I'm at it. Let's see. Because it's possible I'm just being done this whole time. So let's do like the game's gonna run like 5 times now because I tried to run it with RenderDoc. Okay, so that does have data in it, and that looks fine. Like if I do that, that looks about correct. Like, actually, that's not fully correct. Oh, I just printed the thing twice. Because like basically what's happening here is we have, here's like I'll draw a little diagram, just maybe we can group, my eyes, I'm bleeding, ouch. Maybe we can group debug this a little bit. So you have a chunk, right? And each chunk has, I'll draw them in a different color even. We'll do them like dark red. You have 8 neighbor chunks, right? With my awesome paint skills here. Yeah, I gotta be thorough. Every corner has to be represented here. Yeah, for real. It's like getting dark outside too, so my eyes are adjusting to the outdoors. I should turn a light on. I should get up and walk around sometime too. Maybe that would help me. But we have a chunk. But all of these chunks exist. I don't have enough real estate here. Oh yeah, good thing you can just drag. Man, my eyes are bleeding. I might, here, let's make my eyes bleed slightly less. There we go. Yeah, so we have like a bigger region that's actually being simulated though. So this is like a single texture, right? And what I did is I generated a mask that's going to represent all of the chunks within this larger simulation volume that are actually being simulated at every given like simulation step, because the world is broken up into chunks and we're going to dynamically load those in. So we can't assume that the world will just be like a square rectangular region around you. So I'm breaking it into chunks, and then it's going to simulate chunk wise, but within this greater volume, because it's like a single texture. So what I have here is a function. So each mask is just a quad for the chunk that's going to be like rasterized in this shader. And the UVs for each chunk go from 0 to 1. So I'm like standardizing the fact that each chunk renders a quad with UV 0 to 1. So that's like the UV space within that chunk. If that makes any sense. So that's this, this up here. So that works fine for pixels within a chunk, because you can just easily map like a 0 to 1 UV within a chunk to like an area within this larger volume by just it's certainly possible. I'm just thinking out loud right now, actually. So basically every chunk, the issue the reason the neighbor chunks are important is because it's possible for the water cells at the edge of the chunk, they're gonna sample a cell in the neighboring chunk, right? But now that I've broken up my larger texture into like sort of discrete chunks that might not be in order, like spatially, I need to have some sort of lookup that can map a UV from like its chunk space into this larger texture space. So I kind of did that here, where basically I take in a UV. So this is like a UV within this chunk that you're working on, 0 to 1. And the UV can go negative if you're sampling into a neighbor chunk in either like the left or the up direction. And it can go beyond 1 if your sample is in like a rightmost chunk or down. So you can, so basically I then have a buffer that can take, well, what I'm doing is basically I'm generating an index from this. So say for instance, like what's happening here, say your UV, your in UV is like 0.5, 0.5, which is like the middle of your chunk. So we take that as an integer, which actually, looking at this now, I think I found my bug. Maybe not, false alarm. Maybe it's just overly complicated. Let me think. There has to be a better way of doing this. Because like what's happening here is I'm adding 1, because if my UV is 0.5, it goes like 1 plus 0.5. And then offset, we can just ignore that for now. We can imagine the offset is 0. So that's, zoom in. So we're like here right now. So you have 1.5. And then we cast these to integers, meaning we basically truncate the... Yeah, possibly. But yeah, so like I truncate, basically I cut the decimal off, turn it to an integer. And then, so like if I have 0.5, 0.5, my x, my uv.x would be 1.5, 1.5, right? So based on this equation, you would have index equals 1 times 3 plus 1, which is 4. So that corresponds with 0, 1, 2, 3, 4, which is this cell. So you can basically index from a UV, you can index into any of the, I guess, 9 neighbors here. So then from this index, this is kind of dumb here because my little shader language doesn't support 2D arrays apparently. So I need to fix that. It should, it's just broken. It's 8 neighbors plus itself. But yeah, it's like 8 neighbors and then yeah, itself. So yeah, from this index, so this is going to be like a value from 0 to, I guess, 8, because it's like, yeah, 0 indexed. And then this times 9 is just because I'm representing a 2D array as like a one-dimensional array. So this is looking up into a table. And what I have printed on the screen right now, if I delete this so it doesn't break my compile, this big blob of text here is my table. So like the first 9 digits are like basically those indices. And this works because I can test it. Like I can activate this chunk here. So this chunk was just assigned 0, so it's this one. And then if I activate the chunk to the right of it, we can see that this chunk, its index 3 is 0, which means it's pointing to this one. So this table does work. And like its own ID is 1, and now its right neighbor is 2 because I just activated that one. And then this part here is just getting, okay, so we now know what the chunk, the mapped chunk value is. So like we now know what our left neighbor is, for instance. We can look up what its UV like position is within the larger texture. So like in that example, for like chunk 1 and our left neighbor is 0, we would get 0 here, which would map to these values over here, 0, 0. And then the fractional part of this just gets like how far into that chunk are we. So we would be like way over here. And then this just scales us back into 0 and 1 space. So it keeps like the fractional part within the right scaling. And I don't see where that could be going wrong right now, which is really frustrating. It's like either this part isn't working or this part's not working. The full chunk map currently it's 8 by 8 chunks in this simulation. So what's in chunk map? So these are just integers. They're like, these IDs are just which, I guess chunk is it? I don't know how else to describe the ID system. So let me go to the function that we're filling this out in. And again, this is rough code, by the way, so like I will clean this up in the future. I just want to get it to work first. Yeah, so let me think for a second. Yeah, maybe I can re-explain. I'm already like, I'm losing my mind over here. This is tough. So this chunk that it takes in, if its first chunk is 0, down chunk from it is 0.1, but its 9th in array. I guess I'm confused where you're saying that. I think you might be onto something though. If it's 0, where am I calculating it as 3 or 4? You have times 3, try 8. Oh, you're talking about this here? Well, I think this is fine though, because I think it has to be 9 because that's like each interval of 9 gets you to a new like set. And like this chunk here is just like each chunk has a little 9 wide table, I guess, of its neighbor chunks. Yeah. So that's why like I have this chunk times 9 because this gets us like, okay, which it'd be this as an actual 2D array. This is what's happening here. So like this here is just like chunk index. So like this is just, I should really just fix my little compiler because it should work with this. Let me restart. Yeah, it doesn't. For some reason, I don't have 2D arrays working anymore, even though they definitely were at one point. Yeah, I am pretty used to it by now because I actually do it a lot for some of the chunk stuff. But it's like, what was that number? 304. Okay, I think I can get this to work. Let me just, big brain moment here, big brain. Time to lock in. Okay, so it's entirely possible that this is just not working at all. And I almost wonder if it's an alignment thing. Like, it could be that my data is just not even here. And like maybe my, like, is it possible that my buffer isn't even like being uploaded correctly? Because I just can't see how the math is wrong. I'm like somewhat confident about the math. I know I shouldn't be, but. I want to like test, I just want to ensure that I'm actually like working with valid like data. So let's go buffer. One of these is the one. Not that one. Is there a way in RenderDoc to like inspect view contents? Here we go. Oh geez. All right, let's see. Element. Oh, it's broken up by elements. Oh, this is so annoying. This is gonna be impossible. Can I make this not draw as elements? I just want to see like the raw data. There's like a giant list of bytes. Byte range start. Here, let's do byte range start. So 256 times 9 times 4 bytes. 9216. Yeah, actually I might. I don't know if I have that installed. I do have an NVIDIA GPU though. Let's get that cooking in the background. Is it the Insight graphics? I think so. Yeah. I'm gonna get this. I have used this before. Windows. Wait, here we go. Export to bytes. Yeah, I want to see it in bytes. Export to CSV. Buffer. Let's put this in my desktop. Why not? Yeah, I think so. Ouch, my eyes. Don't convert. Yeah, it's still. This is painful. Here, let's simplify the problem. Let me just first just print out, do any of these work? That's the first step. Because we can test these. What is this crazy music? There's like some crazy electro dubstep in the background. Okay. Let's just print these directly. Let's just, I know what the first index of these should be. Oops. Okay, that's something. That actually tells me something. Let me verify. So I just printed what should be 0.13. Yeah, 0.13 is what should be printing out from that. But what I actually got was just nothing. So that's fun. Let's see. Let's try that again. Yeah, so you just get nothing. All right. Okay, that's what about Okay, what if I, just for a test, let's make this a power of 2. Because I wonder if I have some crazy power of 2 issue going on with my alignment, just of my bytes. 256. And I need to change, what was the issue? Possibly large array. That's fun. My buffer is too big. Yeah, about that. Let's make that smaller, I guess. Let's make this 64. No, that's just nothing. Okay. Yeah, thanks for stopping by. Sorry, I missed your message. I got deep into debugging. Hey, how's it going? Thanks for joining. Let's see. Yeah, so there's just no data getting uploaded here, it looks like. That's so confusing. What about DirectX? I'm not even sure how that's possible. Chunk map. Chunk map. What does the generated code look like? 4 to 12. Well, is that true? I'm not sure if that's true. Because you could have a situation here where, so you have float 2 plus, say your UV is 0, 0. So we're at the top left of a chunk. And then our offset would be like negative 0.01, negative 0.01, right? So that would be basically that minus this. Which is 0.9, and then integer is basically a round down. So 0 times 3 plus 0, I guess. Should be 0. And then the inverse of that would be like if you're at 1, 1, and your offset is positive, you would have basically 2 plus that. And then this is again like basically a truncation to 2. Because I know offset will never be greater than, well, 1. So 2 times 3 plus 2 is 8. Is the maximum, I think. I think the problem here is I'm just not getting any data in the shader for some reason. And that's really confusing to me. So let me... I just want to figure out why that's happening first. So I need to make this smaller. Let me just simplify the problem. The problem is I wrote too much code before I could test it. And we have to. Which one of these is the right one? All right, so that actually did something. It wasn't the right value though. Let's also just comment this out for now. I always forget to run with render doc. Okay, so 0.5. Is that what I expect? I think it is. I believe too. I believe. I have faith. Trust the process. I don't think that was right. 1, 2, 3, 4, 5. 0.5 is not correct. This is like the glamorous, just nitty gritty of doing stuff like this. You're just always in render doc. This makes for such engaging content, doesn't it? 0.5, why is it still saying 0.5? What if I make this 1? What is that value? I think I'm certain that the problem is actually just the data making it to the shader. It's just not, it's not correct, it's just garbage. Like now it's just always saying 0.1. Okay. This is painful. This is really painful. I don't even know how to debug this in a better way. What does render doc say the data is? I've never had an issue like this. It's so weird. It's like some weird edge case I'm just not considering. Let's see. So we map the buffer, 88, right? Actually 90 maybe? No, 89? Yeah. So let's view the contents. It's just annoying because this is like not supposed to be the hard part of this. This was not the difficult section. This is supposed to be the easy part. The hard part is yet to come. And it's just like stupid data stuff like this. Like, what is going on? Let's just try this crazy thing. And let's just see if is it possible? Okay, so that works somehow. That's so annoying. So why does that work? $64 times 4. Let's see. Times 2. All right, I'm just gonna roll with this because this kind of works now. Well, not really. All right, let's see. Yeah, that just breaks it. I'm gonna go turn light on. I must have been muted for the last like 20 minutes then. That's funny. Thanks for the call out. Yeah, I stepped away for a second before and I muted my mic and I just forgot to turn it back on. It's okay, you didn't miss much. I was just rambling about the problem. I figured out the problem though. But I'm a little sad because the solution isn't easy. But let's... Yeah, I was just chatting away, just to nobody. So the crux of the problem that I'm having is that, well, I was just programming these buffers incorrectly. I had an incorrect assumption that hadn't bit me in the ass yet until now. Where is it? So I have these little C buffer things, constant buffers, and in DirectX they get compiled into, let's see what they look like. Shaders, wrong project. I'll put shaders. Oh yeah, this is the right project. I'm just losing my mind over here. I figured out the problem though. So output generated shaders, and I should have known this actually. So that gets compiled into this C buffer thing in HLSL. So if we look at this, basically, let me see what's happening here. These constant buffers expect you to be working with basically 16-byte aligned chunks of memory. So then when you read from them, like I'm doing down here, wherever it is, somewhere around here. Like I'm like reading from it here in this like little test code. Like I was trying to access the first element just to like see if it was even doing anything. So intuitively you would think that would get you the first element, like this would get you like the second float in this array if you like index the first one. But that's not actually how it works. It would get you the fifth one because it is in groups of 4. Or no, it would get you the fifth one, I guess. Because it's actually doing this to you internally, and it expects you to read this as like a, I guess, a vec4. So I can't have tightly packed data like this, I guess. What I should be using instead is a structured buffer. I guess a structured buffer. I'm not sure what the OpenGL equivalent of this is though. So I'm thinking what I want to do to fix this. I feel like I just need to implement support for these things. That's so annoying. I'm dying. I was not planning to do that today. Jeez. It's just I haven't actually had to use anything like this yet in the shaders I wrote. So I just, yeah, it's insane. I can't believe that this is how they do it. So let me see. I might actually go to ChatGPT here and just verify this before I lose my mind. Let's turn this back on and compile so we get the shader. I don't even know what this should look like. It's the first problem. Yeah, so I just need to add structured buffers, I guess, is like the moral of the story here. Yeah. Man, this sucks. This might be a showstopper for a little bit, unless I can think of a different way of doing this. Why is graphics programming always so, like, insane? It's always just impossible. It's like at every turn, they just throw something at you. Okay, what can I do about this? There's gotta be a way. There's a will, there's a way. I at least want this working, and then I'm gonna go off and eat food because I'm starving. Because I've been going for like 6 hours already. Let's see. So I guess these would be int 4s, and there'd be 64 of these times 3, because there's going to be some waste. Times 3. So 192, and then we have okay. So I have to write this insane chunk table thing. 9. All right, this will be a massive to-do because I shouldn't have to do this, but I know this will work. So XY. Okay. This should work. I just have to fill this out now in a different way. Hey, how's it going? Four, five. I basically have to like manually pack these into a 4-float. Sure, I can give advice. Possibly. No guarantees. But I can try my best. Okay. Chunk UV. Hopefully this will get me past this stage of this problem. I'm determined. All right, now you're talking my language here. Fast. I say as I write some of the slowest code I've ever written. Let's see. Sorry, 1 second. I'm gonna finish this function really quick, and then I can give my more thorough attention. Thorough. Then I just have to update this part to be that, and like this, and 0, 0. Welcome back. I have made a little bit of progress, and that I know the problem now, and I'm just writing a hacky solution until I have the motivation to fix it correctly. Cannot cast double to float. What is this talking about? Yeah. The problem was that it was trying to read the memory as, oh, I have some negative numbers in here. How'd that happen? Let me make sure that's fine. I have just a somewhat custom theme in here, and I have a little plugin for my engine that I wrote. So that's what you see at the bottom. All right, what happened? Did this do anything? I really hope this is it, you know? This should be the working version. Yeah, I do actually. Unfortunately, because it's a pain. I was hoping I could get this water working somewhat quickly. Let's see. Where's this draw call? Here it is. NaN, negative number, interesting. Nan. So if I at least do this one, what happens? Is that what I expect? 0.12622. I think that is what I expect, actually. Yeah, there we go. That's something. There's progress. Not full progress, but that is some progress. Now this might be broken still. So chunk. Oh yeah, this should be +2. Alright, moment of truth. I'm afraid to see what happened to the frame rate after all of this shenanigans. Sometimes I miss a draw call where the update happens and it's just like, alright, I guess I have to capture again. Yeah, not a number. It probably is. Oh, jeez. Well, in theory, 0, 1, 2, 3, it should be this one. This is just laborious. I feel like I'm doing more just brute force than understanding at this point. NaN, really? Not a number. It's failing to get a number from that. What is this value? Maybe I just print this value. Yeah. Going insane. At least I know what the problem is now. Yeah, so that's -1, which is really weird because I guess that could make sense, -1. Maybe that is what I expect, now that I think about it. Grid. What was I passing to this? Yeah, I was passing in this random chunk. We need this one. This, ideally, whatever value gets printed in this channel, I just want to see like the chunk's ID in that channel. Like that's, once I see that, then we're in business. Because the rest of the stuff isn't actually that hard. It's just like the stupid data processing. Like, here we go, here we go. All right, we're in business. Finally. I'm so excited to see values. I'm looking at this little value down here. So this one's 0, 1, 2. All right, now if we go back here and we plug this in, it might work. It might work. I just want to see that smooth spectrum of colors. That's all I want. All right, let's see. Do we have a spectrum? Not quite. No spectrum. Okay. Damn. We were so close. Let's try this. No, it doesn't. It's a fixed. All right, here we go. We have something. Once again, something. So we go from that to that to that. So now we're in UV space. So we're getting the chunks in the correct UV space now. We're not getting the fractional part for some reason. So we're losing that. Fractional UV, so this might be broken. Oh yeah, I have all this debug code up here. That's probably part of the problem. Let's get rid of that. Maybe it was working. I forgot I wrote all that. Maybe it was fine. Oh, there we go. There we go. All this work to get a little gradient from left to right. Jeez. This is the most disgusting code I've ever written. I am so happy to see that gradient. Holy smokes. Ooh, that was tough. All right. That's big. That's huge. That's huge. I don't want to commit yet. I don't want to commit yet. It's still broken. But that's huge. Okay. Now we have to test this one. Does this one work? Because we're not in the clear yet. Not in the clear yet. Oh, I keep forgetting render doc. Man. All right, the spectrum is still there. Still there. Okay, now the test. Actually, I can't really do the test. Okay, that's exciting. We're getting somewhere. We're getting somewhere. Now, I don't even know what to do next. I never thought I would see the day where that works. Now, something is clearly still broken here. But as I activate chunks, I can draw in them now. So like, I couldn't do that before. Now the test is what happens if a chunk is beneath another chunk. Does it cross the boundary? Doesn't look like it. So it can't quite do the boundaries yet. I'm not even sure what's happening at the boundary. It's like trying to accumulate. Oh, it's going over here. Interesting. This is water. It's turn up my frame rate. Yeah, I'll turn my frame rate up. Let's put it back to like, I'll put it 144, something reasonable. So as water goes down here, it's yeah, I guess this does make sense. Yeah, it's drawing up here because that's where the mask is. So it is crossing chunk boundaries now, actually. Did I actually? I think this is behaving correctly now because I don't expect it to render like in the right spot anymore because I'm like breaking it up now. Now the actual, the simulation shouldn't be entirely broken though, so I need to fix whatever's wrong with that. So it's not this, is it? It could be a million things wrong, honestly. The fluid's broken. That's what's going on. So where? It's not even the viscosity. It's just, it's not reading correctly from one of these buffers. I think it might be this shader that's actually the problem. I'm just trying to think here what actually could be the issue. So that's fine. That's fine. Yeah. P. So where do I use this variable? Yeah, let me turn off the viscosity stuff actually. This is what it should look like, by the way. I'm currently in the process of fixing it, but I'm doing a refactor on it. This is what it actually looks like when it works. So I'm just in kind of the tedious process of turning this into a chunked system so I can kind of simulate, I guess, disjoint sections of liquid within the world. So I have this broken version, or I have this fixed version here, working version, so I can stay motivated. You know, what's it supposed to look like? What's the light at the end of the tunnel? Yeah, I need to render dock this again, I think. Offset. It's not pulling from one of these buffers correctly, I'm pretty sure. So like that gets to there, which is actually is correct. Yeah, it's the worst part about shaders too is you can't like, yeah, there's no like easy way to debug things. It's like brute force, really. There are like debugging tools for like getting like performance profiling, but actually like getting in and figuring out what stuff is doing, it's just simply impossible, honestly. So like I'm really close. I know I'm close. But I'm not quite there. I'm not quite there. So let's see. Like, is it my offset here that's broken? Like, who knows? Who knows? Oh, let's try it. See what happens. Like, maybe this is supposed to be 64. Who knows? Thought I had another one in here somewhere. Yeah, so it is 128. So I know that's fine. See, like, I have to get rid of this debug text. Can't see anything. So like when the liquid leaves the bottom of the chunk, if I activate this one, I expect to see it here. Because as I'm like allocating active chunks, they actually like assign themselves sequentially. It's kind of confusing. So let's see, offset, color. If I remove, just to simplify the problem here. So like I know that this is always going to be the offset. Oh, something started happening there for a second. What about OpenGL? Is that a better, different story maybe? Okay. Whoa. It's crazy. Oh yeah, this could certainly do it right here. There we go. There we go. That's something. Bring back some of the turbulence. There we go. All right. Now we're getting somewhere. Look at this. It looks crazy right now because now it's drawing as like chunks disjointly. Check that out though. That is what I love to see. I never thought I'd see the day. Let's uncap the frame rate. Let's see what the frame rate's at now. Okay. 1700. I'm not even sure if that's what it was before or not. Oh, that's OpenGL too. Let me check DirectX. All right, here we go. FPS 0. What's our frame rate? All right, 6,000. We're good. We're in. Okay, doesn't like DirectX too much. I've simulated like jelly or something. I don't know what's happening here with DirectX. Well, I want to put it in the game, and I'll sell the game. I don't know if I'll sell the simulation. Yeah, I'll chalk it up to service tension. Okay, so that's progress, so I'm really happy to see that. I don't know why the, I'm not sure why that broke, the DirectX version, which is interesting. But OpenGL works. All right, now let me fix the rendering now because it looks crazy. So we need to go to the visualization shader and basically just update these. So let me fix the water one first. Yeah, it just loops around from top to bottom rather than like losing itself. So this one just needs to be 1, 2. I basically just need to copy all these. That was so tough to figure out. All right. Offset, it's just 0. Yeah, so I shouldn't see anything now. And then I just have to fix, let's see. Create like a visualization mask, which is like this mask, except, let's see. Just like this. And I think this should work. Let's see. Oh, interesting. All right, not quite, but it's kind of there. Actually, I think it does work. Yeah, it's just kind of busted looking because I haven't updated all the, like the interaction stuff, all the interaction code. So like the mouse doesn't actually know where it is relative to like a chunk of simulation. Yeah, I need to do one more here as well. I need to get the collisions to work too. So we need to get this one in there. Yeah, so I have to fix the collisions now, which is the next step. Well, not really fix them. I just need to like actually address them. And then let's see, what else do I need to do? Yeah, so this takes in position, but it should take like a position and an offset maybe. Because then this needs to just do this. UV offset, and oh yeah, it needs to know its chunk. Yeah, I'm gonna have to go in and clean this up at some point because this is this code looks crazy. Yeah, I bet. All right. Okay, collisions are fixed. Well, hard to tell, but I think they're fixed. Yeah, they don't render in the correct spot though, so I need to fix the rendering. Man, this is just such a project. Holy smokes. Yeah. Okay. So I also need to fix the interaction, so yeah, we're getting there. We're almost there. Once I get that done, I'm probably gonna end the stream because I'm starving. But I want to finish this because I'm so close. Let's see. I need to fix the mouse so it's actually like relative to the new chunk map thing I'm doing. So let's see. I can't even think. All right. So I basically need to take this value and so yeah. Yeah, actually I'm so hungry. Okay, let's think. Big brain again, big brain. So I just need another helper function, I think. So like, let's get rid of these consts, these are unnecessary. Or, let's see. I don't even know what units the mouse is in. Are these in blocks? Like what even are these units? I should know this. Because I have like 3 different coordinate spaces going on and I forget which units each one of them's in. So like, so 64, okay, that's odd. So that look at us, the chunk that the mouse is at, and mouse relative x, chunk relative mouse x. Crazy long variable names, why not? So we have to check to make sure we're not like out of bounds. Otherwise we might just segfault. Yeah, I agree. Or if it's, I guess if it's greater than equal to 0 and classic so then we can get the chunk is chunks.getChunk. Pass in these to get the reference to that thing. And then yeah, it should be. I only have a width because I got lazy because the width and the height's always the same. It should be more like size. But yeah, it should be height. Yeah, they're square. So like I just call it width, but you know. Okay, so we know the simulation index. So the chunks x in simulation space is going to be its simulation ID divided by chunks.width and y, I guess modulo and division. So then our final chunk relative x and y is so we have the mouse position minus the chunk that it's in, and then plus this times 64 I guess because we're just randomly in units of 64. And this has to be times 64. So I think that should give us a chunk relative thing. And let's just print this to see. So it should be 0 until I do something. Okay, interesting. I'm printing something else. Okay. Yeah, so 64. So if we go down here then. Yeah, okay, that looks right to me. Sweet. So now anywhere we use MX, mint. So we have X, Y. So that's for the left mouse button, which I think creates fluid. One of these creates walls too. Okay, so let's try this. All right, that works. If we zoom in, does it work still? It does. Okay, so it's not perfect. There are a few issues, like I'm not sure what's happening here. There's like a phantom. Oh, it might be colliding with over there. I need to write a visualization shader for the wall now too, it seems. So let me just do that quick. How do they implement math? Yeah, I know, it's crazy. So we have this shader, just copy this. Okay. We're so close, so close. Delete that, delete that. I don't need those. And index is just texture wall. It's just that. Yeah, I don't know about that. I'll stick to water. And this has to be a dot shader. And where do we draw the wall here? Yeah. Maybe I should just render the walls as part of the one of the water shaders, because that's going to be the easiest way of doing this, actually. Because in the game you won't actually see the wall. So let me see. I'll just add it to the lava shader or something. I don't know why I have random collision code in here. I think I have no idea. No, because this is like purely a visualization. I don't know why I had random collision stuff. I think I just copy and pasted and they were just in there, just chilling. Okay, so if wall.alpha is greater than 0.5, then we have transparency. Okay, so yeah, this shouldn't do anything yet. And then let's just do a little branch here if okay, this didn't work. Interesting. That's crazy, actually. Imagine making $1 million just for doing some some programming on like machine learning. Okay, did this even sample correctly? I don't even know. It's so hard to see like what draw calls do what. I see. The wall, the collision stuff didn't work. Let me find out why. In fact, I'm just going to steal that from this. Or actually, what am I doing? I'm so close. I'm so close. I just want to be done. It's cool because it like does work now. It wasn't working earlier. Yeah, that's true. I'm so close. I can get this. I'm like 5 minutes away, I think. I just need to figure out what's happening. But then I'm gonna go eat. 5 minutes. Yeah, classic last words. Famous last words. 5 minutes turns into like 50. Visualize lava. Well, I know this code works because I might just not be binding the texture, actually. That could be it. I know it works because the collisions work. So it's not like a crazy... Where do I visualize lava? Oh, I am binding it. Okay, so maybe it's just busted. Visualize lava. Where's the lava? Those 5 minutes are ticking fast. I'll tell you that. They are ticking by fast. Is this not the exact same code though? UV, offset is 0. It's getting the chunk. It's passing chunks. I guess maybe for consistency I'll do 0.5. And then this is the exact same, index, X, Y, resolution. Yeah, I see the problem. It's just not binding. For some reason, it's not binding the extra texture. All right, those aren't right. That's odd. Where do I Initialize lava. Oh, interesting. I say that a lot. 3. Why am I using 3 and 4 here? That's weird. Render lava. Render lava. Should this not be 1, 2, 3? Yeah, there we go. And the output has transparency in the right spot, so now it's just a matter of rendering that. Oh, I see. Okay, we are within 30 seconds. Watch this. It's gonna happen. We just have to put this up here. There we go. The walls are white, so we can make them brown again or whatever, but what's cool is if it hits the edge, it like bounces off. It doesn't simulate into the bordering chunks. Yeah, maybe. I don't know if 50,000 people would be that excited. I'm excited. There are a few problems now with the placement. You can see like if I place along the borders, it kind of bleeds into random like neighbors. But we have, in the last 7 hours, successfully chunked the, I'm gonna call it chunked because that's a fun word. We have successfully chunked the water simulation. Well, somewhat successfully. It's a work in progress. Yeah, neither can I. All right, I'm excited. That's exciting. Still a lot left to do on this, unfortunately, but this was a big step. It's a big step. Yeah, here we go. Here's a fun little visualization. So if I like delete all this stuff and activate some more chunks here, like activate this whole corner. Just place some water. So if I go into the debug renderer now, you can see this is actually the layout that it's simulating on. So like all these chunks are just sort of like disjointly in space, but then they get stitched together here in the end and everything is good. All is good in the world. All right. Okay, but I think I'm gonna go eat. I am starving. My brain is fried. So thank you guys for watching. More people than I expected to show up for this actually, so it was a fun time. I appreciate the help with the debugging, the moral support. I might stream again tomorrow evening too, so we'll see. I'm not sure yet. But yeah, thanks everyone for watching. See you guys.